Eins, zwei.
Hello? Hello?
Ja, das ist. Hello. Good morning, everybody. Sorry for the slight delay, but now we can begin. Thanks for being here. And before I start, I would like to see how many of you are first time at UIKonf? Wow. It's so basically everybody. So everybody's new. Cool. So then let's start with a small introduction. So I would like to invite my co-organizers, Sabine and Maxim, on stage, so that. So if there is anything you need to ask, if there's any problem, if there's any question, we are here. Just find us and ask us. So don't hesitate. In addition to us, there are also lots of volunteers running around. They have the same T-shirts as we do, so feel free to speak to them as well if there are any questions at all. And that's it. So off you go. And since there are so many new people, I would like to spend a minute about the concept of UIKonf. And the biggest thing about UIKonf is we see this conference as a community conference. So you have probably seen the talk selection process where it was open talks and everybody submitted their talks and got feedback and got voting. So we want to really see this conference as the conference for the community by the community. And that's why the most important thing that you should do here is making friends. So we will have lots of great talks, but between the talks we have also long breaks for coffee and lunch. So use those times and the social events and the parties, etc., to get to know people around you, right? And to make this easier, this year we put a little empty space on your badge where you can write what you want people to ask you about. So you can write whatever you want: cars, conferences, software. And be nice to each other. So we have a code of conduct, and we take this really seriously. So any attendees and sponsors or anybody who is there should treat other attendees with respect. So here's the schedule. You also have it in the app. The first coffee break is 11:15, but probably we are running a slightly later, but we'll see. And after the coffee break, we also have in Hall 5, which is here behind the stage. If you walk like this, it should be around here. There is a Firebase workshop. A team of from Google is here, and they will be giving this workshop. And then 1 p.m. we have lunch. Sorry, double click. Triple click. And then after lunch we have another session of talks, and then we have coffee break at 16:15, and then another 2 talks. And 18:10 is official end of day. But we have ambassadors who live in Berlin and know the city and would like to take UIKonf attendees who are out of town to their favorite restaurant for dinner. So we will put out lists during the lunch break and the last coffee break, and then you can sign up for these dinner events as well. So we have 4 supporters this year. eBay Tech, you have seen the stand there. They are our lunch sponsors, so they provide us with lunch. Then we have Firebase. They are holding this workshop in Hall 5 that I mentioned, behind the stage. Then we have Keep Safe, whose CTO is there. Hi, Philip. And Keep Safe is nice enough, and they're supporting us with coffee. So the nice coffee that you get to drink on that side of the venue is sponsored by Keep Safe. And of course, we also have JetBrains, who sponsored the diversity tickets. Okay. So, make friends.
Okay. So good morning. I'm Jeff Watkins, and I have the pleasure of introducing our speakers today. Those of you who were here last year, I started things off with a talk, and I just couldn't get enough. So our very first speaker today is Cate, and when she's not jetting around the world, living the dream of a tech nomad, she's visiting the feminist shark in Seoul, Korea, but she's leading teams of engineers, and she has the distinction of leading teams in a fantastic way. She actually has engineers who want to work for her after she's done managing them, which is remarkable, because most of the managers that I've ever had, I would never work for again. But Cate's going to talk to us today a little bit about releasing software. So I want you to give a warm welcome to Cate.
Thanks so much, Jeff. That was a lovely introduction. And holler at all my fellow first-timers, because this is also my first UIKonf. So I'm really excited to be at an event that I've heard so much good stuff about, and it's really an honor to kick things off this morning. And it's cool when you get invited to speak, because you get a lot more leeway in terms of what you talk about. So for this morning, I prepared for you a talk about raccoons. Does anybody else love raccoons? All right, give it time. I have 30 minutes to change your mind. So I'm at heart an engineer, but like Jeff said, now I mainly run engineering teams. And there are a lot of things that I love about my job, but I definitely miss writing code. And so since the end of last year, I've been leading the mobile team at Automatic, where we work mainly on WordPress. So it's a 28-person team, so things got super meta for me, because I manage managers now. And when people talk about engineering management, they talk about herding cats. So for example, here's a quote about engineering management. "A man who carries a cat by the tail learns something he can learn no other way." But Mark Twain is a little dated because, women can traumatize cats too now. I really like to think about raccoons rather than cats, though, because raccoons are cuter, smarter, and more inclined to wash things. But it is true that raccoons do what they feel, and sometimes that's awesome. Like, look at this raccoon, right? Like, she is riding a crocodile, and frankly, I admire her so much. This raccoon is everything I want to achieve in life. And sometimes it's not awesome, so like, this raccoon is stuck. Poor guy. But this raccoon is really trying to live his best life because he is trying to break into a tank. It's just quite hard to break into a tank, and so now he's stuck. And maybe all he needed was someone to say, like, hey, buddy, I get that you want to drive a tank because, like, obviously that would be awesome, but that hole is really pretty small, and have you thought about riding a crocodile instead? And so when I was thinking about what to talk about, I wasn't sure if this was the right talk for you all, because I bet you all get to write a lot more code than I do. So, come and find me in the break and tell me what that's like. But do something with me. If you've had a good manager, can you please stand up? Okay, great. And if you've been part of a high-performing team, can you please stand up? One thing I didn't think through is how this would go if your manager was here. So, right now, if this has been the norm, please sit down. But if this has been the norm, please stay standing up, and otherwise sit down. Okay, one person, 2, 3, all right. So, the people standing up, maybe this talk isn't for you, but there are more excellent raccoon pictures. It is, I believe, worth staying for them alone. And for the rest of you, this talk is for you, right? We work in a pretty dysfunctional industry, and it is really hard to find a great team in a healthy work environment. But it's even harder when we don't really know what to look for, I never got to be part of an inclusive team until I ran one. And we make better decisions when we go towards something that we believe to be good than when we go away from something that we know to be bad. And so I'm hoping I can talk a bit about what a functional team looks like. And so you can push towards that in the teams you're on currently. And when you look for what's next, you have some ideas about what to look for. So there are plenty of think pieces on the internet, I'm sure you've read a number, that will offer you a silver bullet to fix your engineering team. And for mobile teams, the silver bullets are normally React Native and product pods. So let's take a moment to talk about React Native and how it's probably not the answer to whatever problem your team is currently facing. I mean, if your problem is that you want to write your iOS very boilerplate UI code in JavaScript, it might be the answer. But otherwise, it's probably not, right? Because if you have anything interesting, you're most certainly going to have performance problems, especially on Android. So, React Native is a technical solution to a social problem. And it turns out Facebook has some very unique social problems. And those are probably not the answers for most of us. So I'm not going to offer you any silver bullets today. I'm going to talk about predictability, prioritization, connectedness, automation, and accountability. And raccoons. So that goes without saying. A predictable team has a regular cadence, right? You can set goals and expectations around when things will happen. But one of the challenges we have on mobile is we ship compiled code. And most advice about improving team velocity is you just need continuous delivery. Just ship as many times a day as you can. And if you break prod, just be like, YOLO! And so here's a really fun story about a simple mistake on an iOS build, because an early build of the much-anticipated Gmail for iOS app broke notifications. And so this really annoying prompt would pop up constantly, which users couldn't do anything with. And it ended up being pulled from the store. And so I'd worked on that team, not when they did that, just to be clear. And I sat next to them at the time, and so I have this visceral memory of that, because it's so terrible to have to pull your app from the store, And that was 2011, and things have really improved since then. We have better continuous integration. We know what is signed with what certificate. And the App Store's a lot better too. Wait times are shorter. You can expedite an emergency bug fix. In Google Play, we can even do staged rollout. How have we been living without this? But you can't roll back an app. And so with auto update, it's easy to think that everybody is getting the latest version, and this is just not true. People can turn it off. They can be selective about when they update. They can even just go several days without connecting to Wi-Fi. And we have to remember that the typical tech worker, with their high-end device and like fast Wi-Fi at home and at work, it's not the norm. And the worst-case scenarios got less bad, but ultimately it's still the same. And there is no lol, that time I broke prod if you work on a client-side app, There's a frantic patch and test and release cycle and the impatient waiting for the App Store, while users that you would never normally hear for leave really vitriolic reviews, some of them offering physical violence. So one small mistake, several hours to fix, and months of trying to rebuild your App Store rating. And this is why a regular release cycle is so important, but that it's not just about what goes into the deciding to ship on a certain time frame. It's about everything else that goes into it. So how do you build confidence in that release? What's your automated testing like? Do you have manual QA? Do you have internal users? Do they actually use your app? Do you have beta users? Do you actually talk to them? And can you commit to the release train? Because the thing that will most easily derail your release cycle is trying to stick things into it because you just don't want to wait until the next one. And this is why an effective release cycle is 1, short, and 2, rigid. Short because people are more willing to wait if they don't have to wait for long. And rigid because patching things in and hoping for the best just results in a delayed and buggy release. You might get away with that once or twice, but not every time. And ultimately, when you break the rules, you undermine them. And finally, you have to be willing to kick things off the release train. Feature flags are great, but you have to be willing to say about something that is causing problems in the alpha, or FSM forbid the beta, this is not ready to launch yet, and it will have to wait until next time. So a common complaint about mobile teams is that they're slower. And mainly I found this isn't actually about writing code being slower, it's about releasing it to the world being slower. Because even with a very rigid 2-week release cycle, code can be around for up to a month before it finally makes it out into the world. A PR review takes a little longer, it misses the release train, you've got to wait 2 more weeks. And so a regular release cycle means that you can communicate when these changes will be out in the world. And a regular release cycle means that leadership and users will see improvements regularly, and even if it's not the one they really want, they'll be more inclined to believe it's coming. So I don't really believe in deadlines. I believe in prioritization, scope, and regular releases. And I do believe in goals, because an effective team can set themselves goals and meet them. And it's really hard to achieve goals surrounded by chaos, and this is why the rhythm of a regular release cycle is really helpful. And beyond that, prioritizing what's most important and why, and scoping what's a unit of measurable improvement, these go a long way. So these things are not rocket science, but they require much of the discipline required to make a release cycle regular, like a commitment to the realistic and a willingness to say no. So a team that's clear on priorities, when you ask them what's important and why, they can answer. It's amazing how rarely people can actually do this. And one challenge we have on mobile is that company leadership, they tend to be dominated by iOS users. And so Android can sometimes feel like a bit of an afterthought. You all might be okay with that, but the Androids on my team are not, So if you ask a person on your team, what is your top priority as a team, can they tell you? And can they tell you why? Can they tell you how their work fits into it, or if it doesn't? And do your actions and the actions of leadership, do they align with that top priority? And do the team priorities align with the company priorities? The challenge of team priorities is often not deciding what they should be, right? But deciding what should come first and being consistent in your actions so that it aligns with that. So a sustainable product has both growth and retention. And because mobile is growing and desktop is declining, your mobile experience, and this includes the web too, really needs to effectively onboard new users. But app downloads are declining. And so I feel like the era of that there's an app for that is over, because of course there's an app for that, but does it deserve to take up space on my phone? And the users who install your app on their device and use it regularly, these are your most engaged users. They have made it past onboarding, and they've figured out what it's for, and so how do you maintain that engagement? And one thing is looking at if there's anything broken that might drive people away. Different products have different priorities, but it's important to consider both your new user experience and your existing user experience. Over time, to be sustainable, you have to balance both. If you onboard people into a bad experience, you will drive them away and they will never come back. But you do need to focus on your onboarding process in order to grow. So there are 2 apps that I've abandoned for cause, and I resent it. I'm still holding a grudge. And both of them are gamification apps. And the same thing that happened on both of them. They lost my streak. So I had a Nike Fuel that had a hardware failure, and a Duolingo, offline didn't work, and it lost my 100-day speak in Spanish. No bueno. And so another example of that is actually WordPress. Years before I worked at Automatic, and I lost a blog post when I was trying to write one on my iPad. And I was taking notes in a talk, so there was just no way to get it back, and I never forgave it. I stopped using the app, and I switched to using a notes app in Simple Note instead. And so people complain a lot, and technology is fallible. But whatever your product, you have to understand what your UX catastrophe is. And for a writing app, it is absolutely content loss. And for gamification, I think it's kind of unfair losing. But what should come first? What comes first is a balance between company, team, various possible forces, new users, existing users, money, growth. There can only be one top priority, but that doesn't mean that the team only works on one thing. Every team has to balance maintenance and feature work, but you need to carve out the space for your top priorities such that people actually work on it and it actually gets shipped. You can't say no to everything that isn't number one, but you have to say no enough that number one actually happens. And priorities need to be communicated frequently with reasons and progress, and you communicate priorities not just by what you say about what is the priority, but when you say no to things, and in how you spend your time. I like to use data to tell a story. So if you can measure something, then you can use that measurement as an indicator of success. But since you manage what you measure, I like to have 2 metrics to make it less easy to game. So top priority on my team right now, we have 2 metrics that we're looking at. One is user success rate in this action, and the other one is support volume from users trying to achieve this action. And these 2 numbers show up every time we discuss it. And user testing videos of users struggling to complete this action, these round out the numbers, and they help engineers empathize with the problem and the people it affects. So you also have to align your actions with priorities. I started managing a designer for the first time ever pretty recently, and I had no idea how to manage a designer, so guess what? I got it wrong. And the way I got it wrong was that I was can you just look at this little visual thing, And it turned out that the things that I thought were the design equivalent of code review were not the design equivalent of code review. And so I kind of paid attention. I was wow, this is a lot more involved than I thought it would be. And he also was hey, you're really stressing me out. So we aligned his work better so that he could focus on his top priority. And a lot of the other things just have to wait for a while. One thing that can be a challenge for mobile teams in particular is that Android is the largest and growth platform. So this is 2015 to 2016. Android grew by 7% and iOS declined by 11%. But depending on what you're building in your market, Android might not be your biggest platform. If you're building an app for rich people, maybe in React Native. But it's definitely an important one, right? But tech company leadership dominated by iOS users. So it doesn't matter how much you talk about Androids being important. If you only use the iOS app, no one will believe you. So connected team, people work together and they take an interest in each other. And this really doesn't mean that everybody has to be friends, but it does mean that they're friendly. And I think one of the problems we have on mobile is that we lack this clear model for mobile infrastructure. And so we have these endless discussions about oh, should we have product pods? But regardless of what your mobile team looks like, a product pod's a mobile team, some new configuration that has not yet been think-pieced on Medium, you have a challenge of connection. And in a dedicated mobile team, how do mobile engineers connect with engineers working on front-end features? Or do engineers developing the API? Was the API written with mobile in mind, or does it work on someone else's machine? And often the answer to this is you just need to have product pods. And to be fair, people have been known to build an API that actually works for mobile that way. But a good app is not just a collection of features. It is an architected thing that has some components that are shared throughout. Some notion of user identity, networking, a database layer. And ideally, it follows some standards patterns that, I'm going to get really radical here, are possible to write unit and integration tests for. It's also going to need to be mindful of memory management because mobile is a constrained experience, not just by screen size. So this is a joke about microservices, and so the first raccoon says, I split the application up into 7 microservices, and the second raccoon says, so you have 7 teams that hate each other. This is not a good way to run any team, but there is no microservices architecture for mobile, other than maybe splitting your app into 7 different apps because the teams don't like each other. But so regardless of your configuration, people are going to have to, once again, I'm getting really revolutionary, talk to each other. And when you organize teams to better facilitate some kind of communication, you make the other kind harder. And since, we don't have this microservices architecture, there's no ways for one team's architectural decisions not to affect the rest of the people working on that application. Bonus, we're still evolving our patterns and standards, So there's not really currently the concept of a mobile infrastructure engineer. And great mobile engineers are normally pretty product-focused. So, how's that move to Viper going? How much of your app is written in Swift? And how's that networking layer that y'all wrote 4 years ago working out for you? So let me guess, behind schedule, around half, not so well, we don't like to talk about it. But we can't make people like each other, so what are we going to do? Well, the best way to get 2 teams to fight is to give them conflicting incentives. So if you incentivize one team to ship as many features as you can as fast as possible, and you incentivize another team to maintain 0 crashes, then you can sit back with some popcorn and watch the show. But if you incentivize one team to move some metrics about user engagement and happiness, and another team to maintain sustainable execution, then it'll probably be a little less like Robot Wars and a little more like a functional work environment. If your app is badly architected, everyone will pay for that every day. If your networking code is a mess, it will bleed through your entire application. So if you invest in the things that make everyone more productive, then everyone will probably be more productive. Things are harder to explain to business and product people, but every team should have some maintenance time, and the thing is to be very strategic about how you use it. And you need to build a team. The easiest way to build relationships is to unite against a common enemy. And this is a short-term strategy and not conducive to long or medium-term good work environments. Amazingly, this is news to some people. But your team is not just the one denoted by the org chart. A team is a group of people who work together to achieve a shared goal. So ignore the org chart for a moment and think about something you're trying to achieve. Who is on your team? Who do you need on your team to be successful? And now reach out to them. So let's talk about automation. So this maybe seems like an out-of-place thing in this talk, because prioritized, connected, accountable, all these fuzzy people things, but automation sounds like proper developer work, much more fun, right? But think of automation as documentation, but developers will actually write it. Without automation, it's really easy to have random esoteric things that very few people know how to do. It's much harder for others to take over processes like builds, A lot of time is either spent on manual processes that are really straightforward to reproduce, and then either bugs are missed because it's boring and inconsistent, or it takes time that could be better spent on other things. So what can we automate? Automate builds. For the love of all holy things, automate your build. If you commit to a predictable release cycle, you'll end up investing in automation in order to make this happen, because otherwise it's just too painful. And this can be kind of like a chicken and the egg problem. You're we should have regular releases, and someone's but we need to automate all these things. Pro tip, nothing encourages people to automate all the things than saying, yeah, let's just commit to the release cycle, and it will be horrible until we automate these things. Write tests. I really cannot believe that in 2017 I'm still trying to convince people that tests are important, although frankly there's a lot of things I can't really believe about 2017. So one of my current work hobbies is noticing GitHub threads with very standard testing steps for reviewers and commenting, this would make a good automated test. Other common GitHub comments from me are, please write some tests, and I like these tests. It's important to give positive reinforcement, you know? And so I just need to note that with testing, it's not just a question of writing the test, but also having an architecture that makes writing tests possible. Linting, style guides, right? The purpose of a style guide is so that you never discuss it again, all right? I once witnessed a centi-thread argument about whether it should be var equals const or const equals var. Like, who has the time to have that kind of argument? Apparently, I worked with a lot of people who did. And like, you can automate your style guide, so your IDE applies it, and that your code review tool applies it, and so that your reviewers don't have to. When code review is done well, it is a great collaboration tool. In a dysfunctional environment, it is the first place that conflict will show up. And one positive, but let's be clear, insufficient step towards productive code review is eliminating nonsense arguments about spacing. So tooling on mobile is still behind, but it is getting better. And things can be a bit more painful to set up, but if you make the time, it does pay off. But part of it is having that time. You know, when everything is super frantic, there's no time to automate painful things to make them less painful. And the anti-pattern of automation is over-automation. You know, I'm sure you've worked with people, maybe been that person, who crafts some elaborate system that only they can use to solve some minor problem that only they can see. And pragmatically with automation, taking the things that are most painful and most tedious and hard to socialize parts is a great place to start. So on an accountable team, people can have expectations of each other, and this includes leadership. But you know, all the other things that we've talked about often result in mobile being a bit disconnected. You know, server-side changes can break clients. Mobile developers take the heat from users and from leadership. And this can lead to resentment, you know, which makes accountability really hard. And accountability comes last because it builds on everything else. Being erratic undermines accountability because the chaos can always be blamed. Lack of prioritization undermines accountability because who's to say what actually was most important? And on a disconnected non-team, you know, who even is accountable and what for? And the less a team is automated, the more crucial but repetitive things can really fall through the cracks. If you want to hold someone accountable, though, assuming you're not a sociopath, it needs to be clear what you're holding them accountable for. But you individually holding people accountable doesn't scale. You know, in a healthy team, people will hold themselves and each other accountable to their team. So I want to tell you a story about the worst manager I ever had. And because he like hid deadlines and like concealed missing information, and you'll be shocked to hear that the product and team was eventually killed. But you know, one time I told him I was worried because we'd missed this deadline, and he said, "What deadline? There was no deadline." There was a deadline, okay? He made it impossible for other people in the team to know what was going on because he thought people should only talk to him and anything else was gossiping. And so no one on the team could hold anyone else accountable because no one knew what was going on. And so it was really kind of farcical, but the best way to tell that there was a deadline is that the tech lead on the team would disappear. So like one time he disappeared for 3 days to search for a cat. We had this meeting, which was like a post-mortem about why this team was a disaster and couldn't ship anything. And the tech lead, like, he made some subtle digs at like another dude on the team, and then he said something super inappropriate to me. And there was this uncomfortable silence. Of course, a lot of people came up to me afterwards to be like, wow, that wasn't cool. But, you know, in the moment, they stayed quiet. And my manager was in that meeting, but he did not handle it, you know? So I was like, I wasn't okay with that, and I was like hoping he would deal with it, but he didn't. He said, oh, well, you should tell him. And I was like, okay. And this is probably what we should expect from a guy who dealt with deadlines by pretending they didn't exist. And he didn't say that about anything else ever. This was the first time I've been encouraged to talk to that dude. So I got this dude one-on-one, and I was like, I told him everything he'd done to annoy me in the previous 6 months. I told him why what he'd just done was super inappropriate, and I shared with him my conclusion, which is he had no leadership skills. And so you may be surprised to know that this did not go well. Yeah. And so in my defense, I was right. Like, this guy spent 4 months reinventing how to architect an Android application and 8 months shipping something which, for the whole time that was happening, included this thing of 2 weeks of UI polish. Anyway, and And when, the team he ran was a disaster, and when that was clear, he disappeared for 3 days to search for a cat, right? Like, somebody really needed to tell him that he was terrible at his job. But I was not the right person to do that. Firstly, I was a ball of rage, so I gave him feedback he was never going to listen to. And secondly, I was trying to hold him accountable for something that he hadn't agreed to be accountable for on a team with no norms or culture of accountability. And so this isn't how you start building a culture of accountability. It's not where you go, wow, I don't want to deal with that. We should have some peer accountability in here. That is not how you do it. You have to start smaller, and it really starts with holding yourself accountable. When we move into leadership, it's really easy for our work to become less visible. And the output is the team, it's no longer our individual work. And good leadership and management are a lot of work, but often in this nebulous way that's hard to quantify. If our work is too visible, it's probably a sign that we're either doing the wrong things or we're taking too much credit for the work done by the whole team. And often we demonstrate accountability one-on-one. We schedule one-on-ones and we show up to them. And we listen to what people say and we follow up on it, even if we can't fix problems right away. So now my work is more meta. I write an internal blog post every week where I share the things that I've spent time on and sometimes the less concrete things that I'm just thinking about. When I was a manager of ICs, I would just post my stand-up every day, same as everyone else. And sometimes it's just like one-on-ones and code review. But I find being transparent about how I spend my time goes a long way, even if my outputs are less concrete. And you can't make somebody hold themselves accountable, but you can encourage accountability. I think stand-up is such a great way to do this. And I really love writing stand-ups in Slack because it doesn't depend on everyone being around at the same time. And if someone forgets what they thought was important in the morning, they can always scroll back later. Stand-up forces some people to start their day with some kind of intention about what they want to achieve. And you can also ask people what they hope to achieve in a given period and then see how that goes. And giving people the opportunity to surface the things that don't go to plan is really important. Inviting accountability by asking questions before giving feedback or assigning blame is really helpful because it's much more powerful when someone owns up to what they need to do better than when you tell them. And so code review done well is such a good entry point into peer accountability because this is when people look at each other's work and give each other feedback and ask hard questions. But how do you get accountability outside of code review? Well, a lot of that is about encouraging a non-judgmental space where people can be open about what's not going to plan. There is nothing more toxic to a culture of accountability than blame, because only when people feel like they can own up and they can ask questions of each other without seeming judgmental, will they actually do so. So the big thing I want you to take away is this idea of thinking in the medium term. Short-term thinking comes back to bite us very quickly, and long-term thinking optimizes for a future that we're probably never going to get to. A lot of what we've covered here is this mindful investment in the important rather than perfection of everything, and in what we build and how we go about it. It's also about doing the hard thing. So there's no silver bullets because a team is a complex system and everything affects everything else. So I'm going to close with 2 observations that I regularly make to new managers who complain to me. And the first is, congratulations on not being a sociopath. I give A++ advice, y'all. So a lot of hard things, like hard conversations, hard decisions where you have to disappoint somebody, they are hard, and there's a limit to how easy they should be. If things are hard, it doesn't necessarily mean that you shouldn't be doing them. It might just mean that you're not a sociopath. And the second is, this is why most teams are dysfunctional. Because most people don't do this work. And so this has been a soft talk. I really hate that phrasing because humans are so much harder than machines and also more inclined to stab you. It has also been a works on my machine talk, because the thing I have not even begun to touch upon here is the work I've done on myself to be someone who can serve my team to this extent. Coaching, mentors, the amount of time I spend in the gym, it is emotionally hard and really draining. And the easiest way to set yourself up for failure is to not take care of yourself so that you can't do it over the medium term. So healthy teams are made of healthy people, and so we take care of ourselves so that we can take care of each other, because together we can ride a whole family of crocodiles, or at least steal a car. Thank you. So speaking of hard things done together, organizing a conference is a tremendous amount of work, much of it to ensure things that hopefully you'll never notice. So can we have some more applause for the organizers who put so much work into creating this great event? Thank you.
Great. That was fantastic, Cate. So I want everyone to email the link to that to my management, please. I think they will really, really benefit from it. Or actually, I know I will benefit from them getting the link to it. That was just adorable. I love raccoons. Except in person. Raccoons in person are scary, scary creatures. So our next speaker is Maciej, and he got drawn into the computing field through computer games, like I think a lot of us have, although I think Maciej may have gotten more interested by Lara Croft's Bottom than the pursuit of exploring virtual worlds. But he recently picked up the guitar and has been playing music with some friends of his. And today he's going to talk to us a little bit about reviewing all the things, correct? Absolutely. So I want you to give a warm welcome to Maciej. Good luck.
I work in an amazing team. The only argument we had in the past was about merging source code directly to development branch, to the main development branch, without conducting a code review. Sehr geehrte Damen und Herren, ich heiße Maciej Piotrowski und ich bin ein iOS-Programmierer von Beruf und Mitbegründer von Swifting.io Blog. Good morning, ladies and gentlemen. My name is Maciej Piotrowski, and I am an iOS programmer and co-founder of Swifting.io blog. Today, I will be speaking about the importance of code review and reviewing all the things. Why so? Because for the past years, I've done hundreds of reviews. The other argument behind speaking about this topic today is because, in my opinion, it is important. In my opinion, quality should be more important than frivolity. Reviewing a code will lead to have a firm and strong source code foundation, will distribute knowledge evenly between developers. And last but not least, because I've learned from an expert. I was attending a workshop led by Chris Aithoff, and he reviewed my code a few times. So I've learned from the best, and this is why I'm speaking about this topic today. But I want to start this presentation with a real-life example, not strongly connected to the programming world. Jeff has told you that I like music, so let's begin with music. I have a friend. She plays violin in a confusion string quartet. Music is great because it connects people, it can strengthen positive emotions and negative ones as well. And it can connect people just as it connected a friend of mine with her musicians. And to experience you better what I'm about to say, I would like to invite one of my best friends on the stage and a co-founder of the Swifting.io blog. He is also a violin player. Let's welcome Bartłomiej Woronin. So, before an important performance, musicians go to the certain place and do a rehearsal of their performance. They unpack their instruments, sit on a chair, they can tune it up a little bit, connect some compartments to the equipment, and that's obvious that musicians tend to play music. So Bartek will also play music in a bit. There are some other fancy equipment parts. I don't know what to call them. Yeah, musicians finally bring out their notes and put it on a stand, and they start playing music. So when musicians are rehearsing their music, they sit in a perfect circle so that everyone see each other's faces, hear each other's instruments, and they can check whether each instrument creates a perfect sound. And if all instruments create a perfect harmony during the rehearsal, musicians do review their work. Look what you've just done. You were able to enjoy Bartek's music and review his work before his next performance. Bartek, it was great. Thank you very much. So musicians review their work just like programmers can review their code. I'm speaking for about, 5, maybe 10 minutes about code review, but I haven't even explained what it is. So code review is an action, a process of finding and fixing mistakes overlooked during the initial phase of software development. It can improve quality of code base, and it can also improve skills of the whole development team. There are a few kinds of code review. First of all, we have peer review or peer programming. This takes place when two programmers are working together very closely. One person writes code, the other one tells the first one what to do. And they're reviewing their work, sharing their ideas. We can also have a formal code review. This happens when we, for example, use an online tool that shows differences in a source code. And we can comment on them, and we can also have a documented review process using an online tool. And for me, there's also a third kind of code review. I like naming it as show me your code review. And it happens when a person comes to me and asks me for a help to solve a certain problem. Then I go to them and I have a look at their monitor, at their source code, and I can review their work, share my ideas, maybe improve something. There are two aspects connected to code review. Those are ego effect and good code review culture. Ego effect is a psychological aspect. It makes people strive for excellence. It makes people do their best at their work. Because if we have code review practices at our workplace, team members know that someone will be looking at their code, and they will strive for an excellence, and they will try to shine bright like a diamond, because no one wants to make junior level mistakes. After all, our egos probably won't let us do so. And there is another aspect, and it's called good culture. Establishing good code review culture means that in our organization, finding defects should be welcomed positively. No one is punished for finding a defect in our source code. No one is punished for making a mistake, because we are all humans. We make mistakes all the time. Okay, how to introduce it at our work? We can benefit from ego effect and from good code review culture. And we can still have in mind that good code review culture is not only about finding mistakes. We can always prize our peers for the job well done, for finding brilliant solutions. And I will share with you my personal story. When I started work for my current company, I didn't know what unit testing and code review were. Maybe it's because I'm electronics and telecommunications graduate, and those subjects like these weren't taught at my courses. When I started working for my company, unit tests were conducted by adhering to some test cases from an Excel file. We had test cases and test steps written down in an Excel file. We should follow the steps, click through the application, and write down outcomes in an Excel file. And those were unit tests for us. But we realized that something felt wrong. So we invited an external teacher to teach us how to do unit testing properly. If you want to know more, to learn more about it, I know an appropriate person who can teach you unit testing. So you can ask me about that during a coffee break. But after the training, we knew how to do it properly. So unit testing, done. And learning how to unit test properly also paid off for me privately. One day, I received a coding task. And I was supposed to write an application that does functionality X, and I would get extra point for writing some unit tests. And I had to send the results of the coding task by creating a pull request. When I read this line, I was asking myself something like this. Pull what? A pull request. So when you're using Git flow, when you are using Git repository, you can adhere to Git flow. Usually, during the development, you have the main development branch. You can commit your work to this main development branch and be a very happy person. But you can also diverge from the main development branch. And you can create per functionality branches on which you commit your code, work on new functionalities, and one time in the future you can think that your job's done. So you can create a pull request and use online tool such as, for example, GitHub, where you can comment your work. You can create this pull request so other team members can comment on your work, and you can, based on their feedback and their comments, you can create some patches to your source code so you can still work on this per functionality branch. And when all team members are happy, someone finally approves your pull request, and you can merge it directly to the main development branch. So it felt very cool. I was really excited about those pull requests, code review stuff. So I created a vision. And actually, today I want to somehow fulfill it and share this vision with you. I think that world would be a better place if unit testing and code review were a standard, not an opt-in feature in iOS mobile application development. Things aren't always that easy. When you want to introduce a vision at your workplace, at your department, team, you can encounter some obstacles. And when you go to the project manager, he probably can say something like this. We have only 3 months and 3 developers to deliver a product. So this is a usual estimate at my workplace. So basically, you cannot do it. Okay. But in my opinion, it will also take 30 minutes for a code review. And we will not be spending 3 days for a bug search. Then someone can tell you that we have only fire and forget projects. And this means we develop source code, we ship it, and we forget about it. We will never get back to the source code. Funny thing, at my workplace, we tend to write applications for one-day events, for conferences. I'm wondering whether UIKonf app has some code reviews conducted or unit tests. Yeah, but about those fire and forget projects, I like thinking about those projects not as fire and forget projects, but review and learn projects, because we can learn from others. When they comment on our work, we get feedback from them. We can improve things. We can learn from them. We can also distribute the knowledge about project internals evenly to other team members. But finally, someone says, there's no time. We cannot do it. And I will quote Yoda from Star Wars, The Empire Strikes Back. There is no try. I will cross out the first part of the sentence. There is no try. And I would add, like in old Nike adverts, just do it. It will pay off in the future. But it takes too much time, I know. So, do you know how much time it takes to deliver a drug to market? Is it 1 year? 3 years? It's even more. According to Medscape.com, it takes about 10 years on average to put a drug on shelves in a pharmacy. So, is 30 minutes too long for conducting a code review? All of the drugs are subject to FDA and EMA regulations. FDA stands for Federal Drug Administration, Food and Drug Administration, and it's a US entity, and EMA stands for European Medicines Agency, and it's a European committee that does something with drugs. So every drug is subject to regulations of FDA, either FDA or EMA, and every drug takes part in a clinical trial. Clinical trial assesses properties of a drug. It checks whether a drug actually works, and it consists of 3 phases and 1 post-market phase. And this is why it takes so much time before a molecule becomes a drug that can help people. And surprise, surprise, even software that takes part in business processes connected to clinical trials or drug manufacturing needs to be validated. There are certain regulations for drugs, and there are certain regulations for software. And software validations are processes that check whether software does what it is intended to do. And those also consist of unit tests and code reuse. Speaking about FDA, there is a company called 23andMe, and recently I've received a gift. It was a DNA collection kit. So you provide your saliva sample to the company, to the 23andMe company, and they can check 23 pairs of your chromosomes, and they can tell you from which parts of the world, which parts of your DNA come from. And when they kicked off their business, after kicking off their business, they also had to cease the business for 3 years because they needed to adhere to other FDA regulations. And I was recently filling in some polls on their website that can help in their studies about human genome and human DNA. And after finishing one of the polls, I've read the statement that their studies are published in peer-reviewed academic journals. So I said, wow, even they use peer review. And actually, this is also what we do at Swifting.io. When we are about to publish a work, an article, we use Git flow. We create a separate branch for our article. A person works on an article. We create a pull request so that we can comment on the work. And finally, someone approves it so we can publish our work on the website. Not everyone do it, unfortunately. So let's imagine a story. We work in a company that has a lot of work. We are a software company, but we cannot deliver as much work as we want to. So we hire an external vendor. We give him tasks, and after 3 months, the external vendor comes back to us with the delivered solution, delivered software. But there was no surveillance from our side, so we didn't know exactly what they were doing. And our developers got access to a repository, and they started flicking through source code. And what they could do is only start pulling off hair of head because source code is crappy. There is no use of it. We have to start from scratch because the app hangs when you open it. It crashes from time to time. There are certain tasks on main thread that shouldn't be done on main thread, and it's a mess, and we are very sad. So, should we review our work? Maybe on a daily basis, we do not work on a life-saving software. Maybe we do not navigate through 7 million lines of Boeing airplane code. And maybe we are just not involved in projects that send human into space. So, why the hell should we review? In my opinion, we should review because we can learn from each other. We can learn best parts from our team members. we can improve ourselves, we can improve quality of our source code. We can learn best tricks, we can teach others, we can reduce buzz factor of a project because knowledge about project internals is distributed evenly. And if we happen to write life-saving software or software on which one's life depends, one day we'll be ready because good habits stay with us. I know we're in Cosmos at the moment, but let's get back to the Earth. If you're about to introduce code review or unit testing at your workplace, you can try doing what I did. I did a prank. I wanted to use code review and pull requests. So I developed functionalities for an application on a separate branch. And I created a pull request and asked my peer to review my work. So if you did the same, maybe one day it will become a standard at your workplace. And maybe one day the only argument you will have in your team will be about merging source code directly to the main development branch without conducting a code review. Just review all the things. Thank you very much. Oh, and by the way, this presentation was also reviewed dozens of times. Thank you.
Do you want to take questions? Do you want to take questions?
Yeah, I can.
So if we have any questions, Maciej will take some questions. So I know I have one question because I do neither tests nor reviews because I'm a terrible, terrible programmer. Is there one I should be doing first before the other? Reviews or tests? And it's okay.
In my opinion, you should do both at the same time.
Oh, don't say both. I can't do both.
So unit tests, because Pavel is on the audience.
All right. I'll start with tests then. I'll put that on my list of things to do. I'll get right on that. I guess everybody wants coffee. There's coffee, there's probably tea, there's water, there's other things, perhaps.
Yeah, and we will continue at 11:50. There will be a Firebase workshop in the room 5 if you're interested. Otherwise, we have a main conference track as well at 11:50. Continuing here, you can consult the apps, you can consult us. Have fun.
Eins, zwei, drei.
Welcome back, ladies and gentlemen. Before we start, I have 2 announcements and 1 question. Okay? First announcement. Again, as I said before, we have a Firebase workshop at the back of the room, if you are interested. Then it kind of goes into the second announcement. This building is circular, right? So there are also toilets back there. There is also food station back there, water station, and so on and so forth. So if you see that it's crowded here, you could also try to go to the other side and see maybe it's greener, right? Okay, so second the question. Who've been there last year? Okay. Who's want to hear me sing again? Okay, a few people, I see. So to people who don't know, like last year I was doing the time stretching thing, and basically when there were some technical difficulties, I sang so that we can bridge the time. But I don't do it for free. You would have to actually kind of subscribe. We had a Twitter account where you could just like it or subscribe to it, and then at some point, I would say, like, now I can sing. This time, I don't want to do it over Twitter. If you are interested, we have Slack. You could just post some idea, some songs you think would be appropriate for me to sing, if you like. And if we have enough likes, then maybe I will sing. Depends on all on you. So it's all in your hands, okay? So now I would like to go back to Jeff with our normal program.
So I hope everyone's refreshed. Our next speaker is going to talk a little bit about performance, high-performance architectures. And I know if you're like me, every time you talk to your boss, telling you, use less memory, make it faster, right? You never hear that, do you? So Marcel is going to talk to us about how we can make our apps faster. I'm sure I'm going to pay close attention to, because that's something I desperately need to do. So Marcel?
Thank you, Jeff. Excellent. Thank you for the introduction. Just a little bit more about myself. I've been doing this for about a quarter of a century now. I'm much older, even than I look. And I've been doing specifically performance work, for example, at the BBC, at Apple. And now I work for Microsoft, of all places. Don't really know how that happened. On the To-Do app, and we were previously Wunderlist. And I've sort of distilled what I've been doing for this ungodly amount of time into a book, which you cannot buy right here, but you can get it on Amazon. And I'm going to try to get you, some of those, some insights that I've poured into that, and in particular some of the larger scale issues that you need to get right. So there's, we all know how to do instruments and get that, fine tuning, but there's some other things that are a bit harder to actually get right. And so the outline of the talk is I'm going to make some general remarks, and then I'm going to give 2 examples of specifically some architecture issues that can happen. One is I'm going to talk about some implications of the call-return architecture style that we tend to have, and another example of how layering can just really bite you, and what you can do about that. So first, some terminology. What do I mean with architecture? It's the large-scale structure of your software systems. I think Martin Fowler once said, all the things that matter. More technically, you're talking about components and connectors. The components are the stuff that do the work, and the connectors tell how well the components connect, how your communication style between the components works. And there are different architectural styles. These are kind of like types for architectures. And particular, the ones I'm going to talk about here is specifically call and return, which is pretty much the default architectural style that we use. We're actually so used to it, I think, that we don't even think about it. Call something, get a result back. But there's others. So for example, pipe and filter. There's event architectures, and many, 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 many more. But wait a second, aren't we supposed to make it right and then make it fast, right? And God, we've all read this, right? And taken it to heart. Premature optimization is the root of all evil. Knu said it must be right, and we actually often even just drop the premature, right? Just early optimization, don't do it, and actually optimization is just kind of for dummies. And this is probably the most widely misquoted quote I know of, because there's some context. It's actually, he did write this, but the context was a little bit different. So he's saying, just this, it's not a complete sentence. The start of the sentence is, we should forget about small efficiencies, say about 97% of the time. So only about the small efficiencies, and only 97% of the time, because there's actually the 3% that really matter. And that's the next sentence. Yet we should not pass up our opportunities in that critical 3%. And actually, the entire paper, which is called Structured Programming with Go-To Statements, is really about you should optimize, and I'm going to show you how. And there's a little further back, he says, the conventional wisdom calls for ignoring efficiency in the small, but I believe this is simply an overreaction. In established engineering disciplines, a 12% improvement, 12%, easily obtained, is never considered marginal. And I believe the same viewpoint should prevail in software engineering. So if you get 12% somewhere, Knu says this is worthwhile. And of course, he said performance in the small, right? And when we're talking about architecture, we're actually talking about performance in the large. And actually, there's a connection in that you have to get your architecture right so that you can actually do the optimization at the end. That's the critical part, and that's really what you want to be doing, right? Because it is true that actually, at the start, you don't know where those bottlenecks are going to be, but you better have structured your code that when you find those bottlenecks, you can do something about them. And Apple found this out when they released Tiger. They were done, except they weren't. And then it took them 6 months to get the performance even just barely acceptable, and then they pushed it out the door. And they never wanted to do that again. And then for the next release, Leopard, they actually had a performance team that was responsible only for the performance of the entire system. And since then, actually, pretty much every release has gotten better performance on the same hardware. So that was the general remarks, and now I'm going to talk a little about one example, which is what can happen if you just follow the call-return architectural style. Again, what is that? Well, it's really everywhere, right? If you're doing object-oriented programming, you call methods or send messages. If you're doing functional programming, you call functions, right? You call something and it returns a value, and then the function is done. And you can do procedural programming in Pascal, and it's the same thing. And what could possibly be wrong with it? Well, there's subtle problems, and to see those subtle problems, let's look at something very simple: the description method. Right? Every object has it in Cocoa. And it just returns a string that represents the contents of the receiving class. Sounds simple. What could be simpler? Well, this little program. It just does a description of an array, of 2 arrays, and this is going to crash. It's completely legal. The type checker will say, yep, everything A-OK, and this will crash immediately, right? Because I put the one array inside the other array, and vice versa. And then we have a cycle in our graph, and description goes boom. Okay, well. So description can only handle acyclical graphs. No problem. No, next program. This is actually worse than the other one, because the other one will crash. This one, if you give it enough rope, will crash your computer. So what happens? Well, first, I put an argument on the command line, so I can say how many of these arrays, and it's just doing array description. That's all it does. And then I get some memory statistics, which we're going to see in a second. And then this is really the trick. Again, I put the new array inside the old array and just keep doing that. So essentially, I have a degenerate tree that just goes down, right? However many times. And that's what happens. So at the x-axis is the depth of the array. So at 50 arrays, we're already up to 700 kilobytes, and the shape of that graph should be familiar. That's a parabola, so we're n squared. And the actual, and you can't really see it because it's hugging the axis so closely. Down here is the actual memory that you would need. The other graph is the temporary memory that's used. So if you go up to 1,000 or 2,000, you're going to start running out of swap space. So why is that? Isn't that, I mean, we just messed up our implementation, right? That must be it. No, and the thing is, it's not. It's because the call return architectural style says, I must have a complete result, and then I can move on, right? But at each depth of this graph, I need to then have complete result, and then have my temporary result into which I copy the complete result from the previous depth. And so therefore, this is essentially n times m. And since I've made this degenerate graph, which is just linear, it's n squared. And as long as you're doing call return, you can't really do anything about this. And once you have decided that, well, description works this way in my entire system, and then you discover this, you're kind of stuck. So what can we do about it? Well, we can change the architectural style. Although, of course, since we're in an object-oriented language, we can't just use a pipe and filter directly. That would be the solution. So we're going to write a method that's more pipe and filter-ish, in that it actually doesn't return a result. It's a void, and it gets the argument passed into it. So there is a target, and then we just add to that incrementally. And then we add the opening brace. We iterate over our contents, and then we can do the recursive call. And we don't need to have a temporary complete result. We just have this result that we got actually coming in, and we just add to it. And therefore, no allocations. And that looks much nicer. So it's the same two lines, except they just now hug each other really close. And the reason there's a step function is because malloc actually has some bucketing. And you will also notice that the depth now doesn't stop at 50, but starts at 5,000, because otherwise, again, you wouldn't see anything. And it goes to 40,000, and you could just keep going, right? And again, it's not really that, oh, we optimized the implementation. Yes, we did that. But the only reason we could do this, because it's a different architectural style. And yeah, that was the other. Well, actually, that is the other graph, but you can't see it. Sorry. So description, well, that's not really interesting, right? We don't really want to do that all the time. But so does this actually affect other things? Yes, it does. For example, if you've ever done an XML DOM, that has that same structure, as you call it, and then you get a complete graph back. And of course, we don't do XML anymore because we're cool, we do JSON. Well, NSJSON serialization has the same problem. And actually, it's even worse, right? Because you need to give it this whole tree, so you need to convert everything into a temporary representation. And even if and when you come back, you also need to get this temporary representation, which you then do something else with. And the same with NS property list serialization, same problem. Interestingly enough, keyed archiving doesn't have this problem on the architecture side, but they just screwed it up on the implementation, because underneath, it then uses property list serialization. Which is good, because then at least it means you can compatibly change a decent implementation underneath. It's just the existing implementation doesn't do a good job. So again, what was the alternative? Well, we went to a more pipe and filter style. And actually, I'm a huge fan of the Unix pipe and filter pattern. And so instead of just having this very specific accumulator that I just used in this example, what I actually do is I have a whole class hierarchy of these pipes, and one is a description pipe. And then I can actually also solve the initial problem, because that object, in addition to keeping the accumulator, or actually not accumulating anything and just writing it straight out to standard out or standard error, can keep a track of, oh, I've already seen these objects, right? And then it can say, oh, I'm in a cycle here. I'm just going to say, OK, cycle, and output this. And you get this incremental accumulation of results. And since this is a very simple interface, you can actually compose these together as well. Architecturally, it's just really, really wonderful. And also, because it has a target and it's not linked to this call return structure, it's great for asynchronous code because you're not expecting a result. You're just expecting the result to be written to the target at some later point. So for example, we in Microsoft To Do, we actually changed the network stack to work with this type of pipe and filter approach. And it's really, really great and got us out of callback hell, which we were deeply in before with Wunderlist. I don't know if anybody's been in callback hell. It's a wonderfully warm place, and you really just want to leave. OK, so the next example is going to be layering. And actually, I was inspired by this by an Objective-C I/O issue 4 on core data, and particularly the article on large data sets. So importing large data sets into core data. And of course, that's by definition kind of a performance talk. And since I was working on a book, I thought, oh, I have an excuse to actually look at this. Wonderful. And that's kind of what's happening there. So you take the public transport data that for example, the BVG here provides in this Google Transport feed specification format, which is comma separate values. And you want to have it on your iPhone locally, not so the iPhone app could, in theory, give you information without actually having to go to the servers. Great if you're on a subway. And their idea was, well, we're going to have the Mac read this data, convert it into an SQLite database, and then we're going to dump the SQLite database, copy that over to the iPhone app, and then it's available locally. And when I ran it, I was kind of surprised that it took 22 minutes to convert that data. Now, it's 130 megabytes of data, but today that's not really that much. And locally, then querying that database took about a half a second for a time and place query, which, that's okay-ish, but not really that great. And so, thinking about it, I noticed that, well, we made some assumptions going in, right? That we're going to do this in layers, right? We have our application model sitting on core data and sitting on SQLite. And, being good architects, all of these are best-of-breed components, right? SQLite is fantastic. Core data has been tuned for, is it a decade now? Yeah, more than a decade. These guys are really smart. And I could not improve any of these components up underneath there. I mean, no way. But somehow that architecture, or something in that architecture, is causing this thing to take 22 minutes. And so I was thinking, well, maybe an alternative would be nice. And one of my favorite architectural styles, which is kind of more of a meta-architecture, is the hexagonal, or I think it's also called ports and adapters. And instead of this strict layering, and we have something external underneath sitting, and we build everything on top of that, the hexagonal architecture says we're going to go inside out. Our application model is primary, what's in memory, what we deal with. And then outside world, if you persist it, or we're going to talk to servers, or you do UI, we do that around that internal architecture. OK, so let's go with that. First, look at what data do we have, right? So this is some GTFS format files. The first one, so it's obviously comma separate values, and this is two file types that we're going to deal with. The first is a description of particular stops. So each stop has a stop ID, which is just an integer. a name, and some coordinates, right? Nothing fancy. And fortunately, also, the stop file is just not really that large. So we can just model it pretty much any way we want to. It's not going to really affect our performance. So just do the simple thing, and there we go. So the really large file is, of course, the times, because it records every time any vehicle arrives or particularly leaves a particular stop. That's the big one. That's about the 130 megabytes. Everything else is just noise. And essentially, you have an arrival time, which we don't deal with. We have a departure time and a stop ID, and that's it. So that's the other interesting thing. Very often, the data that you have a lot of tends to be simple. And in this case, that's actually true. So we can model it simply. Now, we just use a struct, a C struct. And actually, we use bit fields, right? Because why would I spend 64 bits modeling an hour? Actually, when iCal did the 64-bit transition, they had that. They had a 64-bit integer for hour, minute, second, day. And it's like, wait a second, guys. You do know that an hour generally, has 60 minutes. That's 6 bits. We don't need more. And you're going to have lots of these, right? It's iCal. There's a lot, you're going to be talking about time a lot. So let's model this, right? 5 bits for the hour, 6 bits for the minute, and our stop index 20 bits. That's enough. That's 1 million stops. We have far fewer than that. And because what we want is to look things up by time, right? That means, that's small integers. We can just sort of index into that, right? And so our search structure is this buckety thing, right? We just say, well, we have, 32 hours in the day. Oh, what? Well, they actually extend the day, so when you at midnight, you don't have to wrap around. So they just model it as what we tack a couple of hours on to the day, and that's fine. And that works, because 5 bits. Yeah. And then we have 60 minutes, and we don't do second resolution on these. And then we just have these buckets, and then we have all the stop times, and we just index that array into the stop times. And because the original data doesn't actually come in that format, we actually have to sort it into that format. And of course, we all know sorting is n log n, best case, except when it's not, right? Because we have small integers. Anybody remember small integers? What can we do when we sort small integers? Yes, we can do a bucket sort. And because we have all this in C struct, we can just allocate those arrays once in one huge allocation. That helps a lot. And then we have to find out how many stops are at each particular location, so we're just counting them. Then as a second pass through that array, we then have to convert those counts into offsets, which is again just adding them up again. And then we do the actual bucket sort, which means we just, when we find a stop with a particular time, we just put the index into that bucket and increment the counter in that bucket. And then actually we do a final step of sorting those buckets so we can search more quickly in them, and that we just use the system merge sort, I think, and that's not really interesting. And so then we have this binary structure, and then we just use fwrite to write it out. Because this is a private communication between these two systems, so we control both endpoints, so why the hell not? And how long does that take? Well, it takes 280 milliseconds compared to 22 minutes. Although the 22 minutes actually included CSV parsing times, which was another 18 seconds, which before weren't noticeable, but compared to 280 milliseconds, it becomes noticeable. So actually, I also spent a little bit of time optimizing that. But I'm not going to go into that because it's not quite as interesting. And so the overall results were actually quite, nice. Using this structure, the time to query went from half a second to 58 microseconds, which is an 8,000 times improvement, which I think is more than 12%. But the time to create is less than a second versus 22 minutes. So that's 1,000x. And the size of the file, although we didn't really optimize for size at all. If I were optimizing for size, I would probably do something different, is also 10 times smaller. So again, we're definitely getting around that 12%, which we think is worthwhile. And this was really low-level optimization, but again, that's not really the core message here, because I was able to do that with the original structure. I couldn't have done any of these optimizations, right? Because all that was fixed by the architecture that I had selected earlier. And again, the interesting thing is, what I had done was really very, very simple. It's not really sophisticated. Whereas all these systems that we're using before are very, very sophisticated. And an afternoon of hacking on any of them would have probably not done anything except prove that I'm not worthy to worship at the feet of the people who wrote that code. But by changing the architectural outlook, I was able to do something very simple that got me 1,000x. Because focusing on the application model first, and then we add the stuff around. So suddenly input was just memory mapping, output was an F-write. And I could add other connectors here, other input-output methods that wouldn't impact what I had done inside the memory model. And that's really the point. And of course, when you're talking about 1,000x performance improvement, that's not a quantitative improvement, that's a qualitative improvement. You can do completely different things than you did before. Right? You can leave out steps, right? I mean, if you have a compact representation that you can send over the network, you don't even need a conversion step. You can do this on the iPhone. If you have servers, you definitely don't need a separate conversion step. They just read the CSV as it comes in at startup and then start serving. Things. And again, if you have 50 microseconds to do a lookup instead of half a second, you can start playing around and add services. Whereas if you're at half a second, okay, with optimization, we got it down to 0.4 seconds, and we're super happy. But you're not really changing the game. And that's really what this is about. It's like, if you have high-performance architecture, you can start doing things that you thought were not possible. And that's really sort of the takeaway. Architecture matters a lot. Call return. We're so familiar with it, we don't think about it. Think outside that box, Accumulators work really well. Pipe and filter is an amazing architectural pattern. Hexagonal architecture. Think about your model first. Don't think about the technology stack first. Don't say, I'm an architect, therefore, I'm going to do core data, and then I'm going to do this. And no. Think about your model. The architecture will come. And you want to enable those future optimizations. And that's the end of my talk. And you can follow me on Twitter. You can buy the book. Or you can also follow me on my blog. Thank you very much. Are we doing questions? Sure. Yeah.
So we got a few moments for questions. If anybody has a question or two for Marcel. I see somebody over there. Wait for the mic.
There's a mic coming.
Hi. Hi, great talk. Where can we find examples of this pipe filter architecture to see some in work?
Okay, obviously Unix. So that's the canonical example of pipes and filters. Then recently, a lot of the languages have acquired. For example, Java 9 has done in-memory. There's Akka streams. A lot of the reactive, the naming is always odd, is actually very close to pipes and filters, although they don't seem to get much of the performance benefits. So I'm somewhat skeptical there. But yeah, I mean, it's a very long tradition, and again, Unix pipes and filters is a great starting point to look at how that works. And what I did here is really just ask myself, okay, if I did pipes and filters not based on character streams and not on processes, but with objects and messages, what would it look like? And that then turns into the code that I used is in MPW Foundation. That's on GitHub. So I mean. And it's very simple. It's a couple hundred lines of code within that larger framework. I should probably just break it out at some point because it is so incredibly simple. The core is a single method that it says, write object. Well, I'm going to take that object, write it to my target write object. That's 3 to 4 lines of code, and then everything else sort of falls out from that. Time? It is. Sadly, I don't have any copies here, which is, I know, a complete oversight. But certainly, if somebody has a copy, I'll gladly sign it. And if you're generally in the Berlin area, I'm from Berlin, I'm here, I will also gladly sign your copy. And they're available on the usual places. It's Pearson and Amazon. And I'm not sure whether there are any local copies. Thank you. There's a question in there.
Hello. What was the final result of your sorting algorithm? You said you used F-right.
Yes.
But the initial problem was referring to SQLite storage. So where did you put the data and how was it queried?
It was in that structure that I showed. Sorry, builds. It was essentially that structure. What I did not show is, which I mentioned at the beginning, is that the actual stop information is just modeled as plain Objective-C objects. And I don't even remember what I did with them, I have to admit.
Okay, but so structure in memory and all the querying does...
And I just F-write that structure out. And the reason I can do that is because it contains no pointers. It's just index information. And therefore, I can just make a memory dump and write that out. And I can read that back in, or memory map it back in, and it'll be the exact same thing. And since it's not a public, I mean, you wouldn't want to do that for a public file format. And you certainly want to at least add a little header, this is version X of that file. This is version 1 is always identified by it doesn't have a header. Version 2 then has a header. And then you just read that in, and then. But I was just having fun with that, so this is not a production level solution.
Yeah. So just to conclude, the querying is performed when the whole structure is loaded in memory, and it's
memory mapped into memory,
yeah.
And because it's completely again, at that point you don't need to write anything, so we just memory map the structure.
Yeah.
And therefore, the operating system will page in the correct information. And since it's not that much, and so that was, I guess, maybe a follow-up question that I'm going to just ask for you is, doesn't this use much more memory because everything is in memory, right? No, it doesn't, actually. Because the structure is so compact, compared to core data, it actually used slightly less memory. And the other thing is because it's memory mapped and clean memory, it means the operating system can actually throw the resident memory out without any problems. So essentially, the memory pressure of this is very, very low.
Very nice. Thank you.
Thank you. Thank you very much. I guess next up.
Thank you so much.
Thank you.
Really great. Really glad to be back. Thank you so much, Marcel. So next we have Thomas. And Thomas is ambidextrous when it comes to software development. He develops both iOS and Android, for which I greatly admire him. I can barely develop for iOS. He's recently picked up Swift development, which means he's got a little bit of extra time on his hands. So while he's compiling, he's been picking up card tricks. He's going to give us a grounding on the basics, the intrinsic stuff of React programming. So I want you to welcome Thomas to the stage. You're doing great.
Hey, it's great to see how many people are here for the first time, actually. Really, really cool. Myself, this is my 4th UIKonf and first time as a speaker, so it feels really special. Glad to be here and talk to you. I'm not seeing my speaker notes. So 1 second, sorry. Much better. Okay. So over the course of the next 30 minutes, I'd like to build a minimal implementation of reactive programming. It's only a few dozen lines of code, but it covers the core concepts of the paradigm. And that should help you build a mental model of reactive programming that you can use while you actually use a real implementation, building it in your app. So what excites me about reactive programming is the fact that it offers a single solution that you can apply to a wide variety of problems, while with imperative programming you might need to use specific approaches depending on the context. So when I say single solution, I don't mean a simple solution, or it can take some time to get into. You need to look at your problem, your app, from a slightly different perspective. So I'd like to start with an analogy, with an example of looking at a thing from a different perspective. And that's with these two photos. They both they look similar, actually, at first glance. And they also describe the same event, namely the last milliseconds of a race in the 2016 Olympics. On the left, you see a regular photo taken with a regular camera. And on the right, you see a photo finish camera. And the photo finish camera is actually an interesting camera because it only takes a picture of 1 pixel wide, exactly at the finish line. And it takes a lot of pictures, like 10,000 a second. And then it can compose a picture like here on the left by putting all those images side by side. And a good property of a good analogy like this is that I have to explain maybe a bit more. I have made an animation where you can see the athletes running by, and it takes those frames and composes them into a single picture. So here we are seeing time pass by at a single point in space, while a regular photo is multiple points in space at one point in time. So two perspectives at the same moment. So why am I telling you this, you might wonder? Well, we can draw a parallel with what we do in our Swift code. So if we look at the regular photo, you could compare it to a regular synchronous call where you get to work with your synchronous data, you have an overview of your data, you use it, for example, like an array. And then the photo finish camera is the other case where data comes in piece by piece and you want to act on it immediately. You really want to use it as it comes in, so you have a callback closure that gets all the athletes whenever they cross the finish line. In both cases, we're actually working with a sequence. One is a regular synchronous sequence. The other one is a sequence of closure calls where you get each athlete in. And then at the bottom of the slide, there's the array notation in Swift, but somehow that only allows us to represent synchronous arrays. Well, maybe if you squint your eyes a little bit, you can imagine that every comma in that notation represents an unknown amount of time between the elements, and then you can maybe describe even a more wider variety of sequences. So what I'm trying to argue is that we can see everything as a sequence, like synchronous sequences, asynchronous sequences, maybe even sequences of one, just with one element. Everything is a sequence. And if sequences are all we have, we also only need one tool, one API to work with them. Let's have a look and find out what that looks like. And let's start by looking at an obvious candidate, namely the built-in Swift standard library sequence API. And that works great for synchronous data. So here we call getRaceResult, returns an array. We can prefix, enumerate, map, join, and we get the result of the race out. If we try to do the same thing to the asynchronous case, it gets messy. Like, I don't really want you to understand this. Just see that it's a bit more complicated to understand. You need another state variable. Swift has no built-in way to nicely deal with asynchronous sequences. We did inherit some ways of dealing with asynchronous sequences, though, from Cocoa and Objective-C. So, for example, with a button, you might do the target action way, where you get a sequence of tabs in the shape of method calls. Same goes for a delegate call, where your delegate, perhaps to update the location of the device, gets called with the new locations as the user moves. And the same goes for the URL session, where you have a completion block that gets called once, in this case, when the response continues. But when the response completes. These ways of working with data are not as nice as working with synchronous sequences as we can do with the standard library with Swift. And so let's look at why it's so nice to work with these synchronous sequences, and it's because they're really nice to iterate over, and all the other operators are built on top of the fact that you can iterate over that sequence. And that's powered by two relevant protocols: the sequence protocol that defines a make iterator function that returns you an iterator, and then the iterator has a next method that you call. You get back the next element until you get nil, which means that the sequence has ended. And this is pretty flexible API, actually. We could try to model an infinite sequence here. With any iterator, you pass it the closure that gets called whenever you call next. So we return 0 and then increment it by 1, so 0, 1, etc. So you can actually for loop over it. Your program will never end, but you can actually work with an infinite list like this. But we could also prefix the infinite list and then actually have a program that stops after printing 0, 1, and 2. And we could even map over it. We have to make it lazy, though, otherwise map will first try to transform the infinite sequence, which it will never finish. But you can map over an array, over an infinite sequence and print whether each value is odd or not. So what about asynchronous sequences? How can we apply these APIs to use asynchronous sequences and work with data as it comes in? Well, that turns out not to be that easy, or actually not to be very practical. So in this is a bit of pseudocode because I didn't want to make it compile. So it can happen that somebody calls next on the iterator, but there's no value available. So you would have to wait with the semaphore, for example, and then when a new value comes in, you signal the thread to continue. But that would actually lead to a for loop that might be blocking, which is kind of silly to think of. So it is a limitation of the iterator protocol that the consumer decides the timing of when the next function will get called. And there's no way for the iterator to say, I don't have a value for you now, come back later. When is later? So to solve this, we need to kind of reverse this API. And instead of having an iterator, we're going to use an observer. That's the terminology used by in reactive programming, at least if you use the RX implementation. So you have an observer, and that has a next function that receives the element. So now something can call the observer whenever a new value comes in. We can actually simplify this a little bit and just define observer as a closure that takes an element. So with the standard library, we have an iterator and a sequence. And now, in an attempt to work with asynchronous data, we have an observer, and we also need a replacement for sequence, and that's called the observable. That's the thing that you can observe as an observer. So let's try that. So we want to support both synchronous and asynchronous data, but let's start with the synchronous case. That's easier. So we create an observable that has an array of values. And whenever an observer subscribes, we just call the observer for each value. So using that, it looks like something like this. So we create an observable with 1, 2, 3. We call subscribe, and the closure will get called 3 times, printing 1, 2, and 3. So now for the asynchronous case, we actually need to add a bit more code. We can keep track of the observers, save them when they subscribe, and then when somebody will append a value later, call the observers again to update them about the new value coming in. So that will work as well. So we can define again an observable with initial values 1, 2, and 3, subscribe to it, and then later append a value, and all 4 values will get printed. But actually, this type is doing 2 things. So it has this initial data, and then also supports data coming in later. And I think we can simplify that by getting rid of the initial part and fix it in a different way. So I get rid of some code, and now we can just define an observable like this, and after subscribing, we can append values to it, and the observer will be informed. But if we would try to append a value before the observer subscribes, that value is lost. Nobody will ever know about it. So that's an issue. So we need a way for an observable to react to a subscription, to a new observer subscribing to the observable. We can do that in a bit, but it's good to remember this. We'll get back to this later. There is a use for this. We'll see later. We can implement it a different way. But for now, let's focus on how we can react to a new observer subscribing. So this is the observable that we will be using for the most part of this talk. We add it has a subscription handler that you give when you initiate the observable, and it defines how the observable should react to a new observer. So the subscription handler takes an observer and can do something with it. And then when you subscribe, the new observer is given to the handler. So when using this, it should look something like this. So we can define an observable that we give a subscription handler that tells the observer about 4 values, 1, 2, 3, and 4. So you actually define the observable in terms of what an observer will see. And then if we subscribe, it will actually print 1, 2, 3, and 4. Because the parameter passed to subscribe is the observer closure. That gets passed as OBS in the subscription handler, and it's called 4 times, easy enough. And that looks a lot like how we work with regular synchronous data, maybe a bit more complex for now, but even the signature for each is more or less the same as the signature of subscribe. But what we've gained is the ability to use, to model an asynchronous sequence, because instead of just passing values 1, 2, 3, and 4, we can also just pass one value and then wait for a second using Grand Central Dispatch, and then pass a second value. And when we subscribe, first 1 will be printed immediately, and then 1 second later, 2 will be printed as well. We can actually use the observable to model a timer. So we can define a function called timer, give it a delay, and it returns a new observable that whenever an observer subscribes, it will wait for the given amount of time and then tell the observer that the time has passed. So we can call the function timer, subscribe to it, and 6 minutes later, your soft-boiled egg is ready. And we can make more use of this, for example, to model network requests and network operations. So we can define a function called response, where you give it a URL and it returns an observable that represents a network request. So whenever a new observer subscribes, it will schedule a data task on the URL session. We're not really handling errors here, but when everything is A-OK, the observer is informed about the data and the response that comes back. Using it looks something like this. So we can define an observable that defines the response from the UIKonf website, like this. And when we subscribe, a split second later, because the UIKonf website is very fast, print is called. So a lot of power in the synchronous APIs from the standard library comes from the fact that you can have operators on your sequences and compose them, map and filter, etc. You can do the same with observables. So let's try to look at how we can define operators on observable. And let's start with a very simple operator. I call it same, which just returns an identical observable. So we return a new observable that for every observer subscribes to the original observable. You can also write it like this, just a small change, where we actually have access to every element as it is forwarded to the new observable. And what we could do is, for example, define an operator called +1 that just increments every value with 1. We can make it more generic by defining an operator called map that you give a function that defines how each element should be mapped, and then call that function for every element and forward the results to the new observable. And if we use it, it looks something like this. So we define an original observable, 1, 2, 3, and then we define a new observable, O1, that calls +1, and then map, and we subscribe to that. But it's important to realize that before subscribing, actually nothing has happened, because everything is defined in terms of what the in terms of what the observer will notice. So as long as we don't subscribe, there's no observer, so nothing will happen. So 1, 2, and 3 are not emitted. There's nothing incremented. There's nothing mapped. But as soon as we subscribe, the values are emitted, and +1 is executed for each value, and the map evaluation is also invoked for every element. But that also means that if we subscribe twice, everything will happen twice. So now 6 elements are incremented and evaluated and emitted. And with this, it's not a big problem. But if you're doing network requests, you can run into some strange situations where you're doing a lot of network requests. So it's very easy to make that mistake. I've made it myself. I have never shipped it into production. But you believe me, right? But luckily, reactive programming makes it also very easy to share side effects like network requests to make sure that you don't do duplicate requests. So for that, we can, of course, define an operator. Let's call it share. I'll reserve some space for the code that we're going to write. So share will return a new observable. And then for every observer that subscribes to that observable, we want to do something. But actually, we only want to subscribe to the original observable when the first observer registers. So we keep track of whether we have subscribed to the original observable or not. And if we haven't, we subscribe. And then inside the subscription to the original observable, we will forward every element to all interested observers. So now we can add the share operator to the UIKonf observable, subscribe twice, and actually just one network request is being executed. So we've seen how we can create observables and subscribe to them and have operators, but now let's look at how we can stop subscribing or indicate that we have had enough. And with regular sequences, it's pretty easy. You just break out of a for loop. But with observables, it makes it a bit harder. And but it is very important to be able to do that, because some observables can take a very long time. If, for example, the UIKonf website would be slow, or maybe you're on hotel Wi-Fi, this observable would take maybe 10 seconds. And all that time, your observer is kept into memory. You can see here that the selected closure is our observer. It's kept into memory eventually by the local URL session. So we need a way, we need to update our observable one last time to allow subscribers to stop subscribing. And we can do that with something that's called a disposable. And it's just a simple closure that takes nothing, returns nothing. But we add it as the return type of the subscription handler. So the subscription handler will have to return something that we can use to cancel the subscription. So, and in the subscribe function, when we call the handler, we also pass along that disposable to the user. So at the subscription handler side, at our network request, it looks something like this. Before we didn't return anything, now we return a closure that when you call it, it will cancel the task. And moments later, the completion handler of the data task will be released, and consequently also the observer. And at the usage side, when we call subscribe on the UIKonf observable, we store the disposable so we can call it later when we don't need it anymore. In practice, this would look something like this. For example, in a view, when you bind it to the view model to receive updates about the title, you save the disposable, and whenever the view is deinitialized, you stop receiving updates because you call the disposable. So we've seen how we can create observables within this and define their behavior within the subscription handler. But sometimes we want to define the behavior from the outside and emit events based on other input, maybe from UIKit. So at the fringes of your reactive programming world, you will need something else because it's not clear how we can solve this. So this submit button tapped is a selector that's called whenever a UI button is tapped. But how do we send that into? How do we emit that button tap in an observable? So what we would want to have is something like this. We want to define the observable beforehand, and then inside the function, we call a send method to indicate that the button has been tapped. But observable actually requires a subscription handler when you initialize it, and the send method doesn't exist, so this doesn't compile. But this might remind you of something that we talked about a little while ago. We had this observable that actually stored all observers, and then whenever you would append later, it would inform all interested observers. So, and in reactive programming, that's called a subject. It's a thing that is an observable and an observer at the same time. So it is a subclass of observable, and the send method has the same signature as the observer. So but we now can redefine it based on the default observable behavior and define that the subject responds to a new observer by just storing it in an array, nothing else. Just store it in an array, keep it for later, and then in send, we actually send items to all interested observers. We actually need a bit more code to make this compile. It isn't really interesting, but for the record. So now in the view controller, we can use a subject. And then whenever the submit button is tapped, we can call the method send. And then somewhere else, we can actually subscribe to that subject and do something with it. For example, what we might want to do is whenever somebody taps a button, he or she wants to refresh the data from the UIKonf website. So what we could do is create a new observable that represents the response from the UIKonf website and call it like this. But the problem here is that we now have nested subscriptions, and they have the same problems or complexity that also comes with using nested completion handlers. There's also no way to cancel this whole thing or to manage this whole data flow from taps to network request as a whole and be able to start and stop with that. So instead we might want to try, instead of subscribing, we might want to try to map. So we want to map every button tap, every void, to an observable representing the response from a network request. But then in the eventual subscribe, we end up with observables, so not the data from the response, but the observable itself, because map returns observables. So we now have a nested observable. We have an observable of observable data URL response. So we can get rid of that using an operator called flatten. I need to define a protocol to be able to do this extension. But let's focus on flatten. So what we want to do is whenever a new observer subscribes to a new flattened observable, we want to subscribe to the original observable and then subscribe that observer to every inner observable that comes by. So, and the end result is that you get an observable that has all the elements of all the inner observables. And we need to add a bit more code to make it also disposable. So back to our view controller, we can now add the flatten operator and then subscribe to the flattened observable returned from that operator. And we actually get the data and the response, and we can do something with the data. So that's how you can compose observables into one. And that's actually the last concept that I wanted to talk about. We've covered today the observer, the observable, creating operators to be able to compose observables, subscribing and disposing of observers, sharing side effects or not sharing side effects. We've covered the subject, and lastly, the combining of observables. So, and that all in a few dozen lines of code, but there is a good reason why real reactive programming implementations are not a few dozen lines of code. Actually, they do error handling and have special cases for sequences that complete. They have a lot of code involving edge cases around or using of concurrency and thread safety, and they have a lot more operators. So it makes sense that those are a bit harder to understand and a bit more sophisticated. So, and if you're interested and want to learn more, there's a few resources that I can advise. There's an excellent introduction to reactive programming on GitHub. There's a workshop this Wednesday, but I'm afraid it's sold out. But if you're going, have fun. And then it's also really good to just get started and start using any of the implementations out there, like RX Swift, Reactive Swift, React Kit. Read the documentation and try it out. And that's what I wanted to say. So thank you.
Fantastic. Thank you so much, Thomas. So I think we have a moment or two for a couple of questions before we break for lunch. So if anybody has a quick question for Thomas about reactive programming. Anybody? I mean, I almost understood it, and I'm about as old and creaky as you can get. Anyone have a question, or are you all super eager for lunch? And if you are, gosh, I'm really loud. If you are, I need to remind you that we'll be back here in 90 minutes. I'm trying to get away from the super loudness. And we'll be back here in 90 minutes, and while lunch is going on, Sally is going to be putting on an accessibility workshop, which you really should go see. She's got some gadgets that you'll be putting in front of your eyes to simulate various vision impairments. I've been through the workshop before, and it's terrific. You really gotta experience it to get a full measure of what it's like. And that'll be in room 7 during lunchtime. So if there are no questions, then there's a question.
Oh, just in time.
There's a question. Excellent.
Yeah, maybe it's a bit more advanced question. I was wondering how you handle back pressuring. So when the observer can't handle the pace of the events that come in.
That's a good question. It might be better to discuss it offline. During lunch, maybe. Yeah? Okay, good.
All right. So I think we are probably going to wrap it up for lunch because something tells me many of these questions are pretty involved.
Yeah, it happens.
Well, maybe there's a reason why I don't understand this stuff.
Could be, yeah.
All right. With that, let's go enjoy some delicious lunch, and we'll be back here at I think it's 2:30. Fantastic. Did great.
Ladies and gentlemen, welcome back. All right. So I have again 2 announcements and 1 question. Like it's kind of my thing this year. So first announcement, ambassadors will have tables after this session over there. So if you would like to grab dinner with ambassadors or you are an ambassador, please, at the next big break, please go over there so that you can mix together and organize these things. First thing. So, second thing. Sadly, we had to rotate a little bit in the schedule. So, we switched Sarah with Rob. So, the first talk of the last session will be Rob, and Sarah will present next day. Okay, and then the question would be, please, Andreas, Oetjen, please raise your hand if you are here. Good to know. Okay, thank you very much. Give up for Jeff.
So welcome back. I hope you all had a great lunch. As was mentioned earlier, UIKonf really is a community event, but we've had speakers from all over the place, just everywhere. Our next speaker, Frank, actually is a Berlin native, and he's going to talk to us about typography and how we can make our apps look just beautiful. So Frank, welcome to the stage.
Hey, how are you? Ready for that after lunch nap? I think that's the next session, probably. I'm excited to be here. This is the first time I speak at a proper developers conference. I've spoken at quite a few design conferences, but this is new to me here, so I'm really excited. So welcome to my introductory lesson on Visual Basic. I just love building programs in Visual Basic. We'd say programs for these things. Actually, I used to love it 20 years ago. I have very fond memories of this. This was how I learned how to build programs. If I recall correctly, there was no Stack Overflow back in 1996. And taking this screenshot was not easy, by the way. I had to install Visual Basic on my Siemens Nixdorf laptop first. Unfortunately, it has no USB, no networking, and no CD burner, so getting the screenshot off of that was hard, also because the file size was larger of the screenshot, was larger than a floppy disk. So I had to convert it first and then put it on a floppy disk, and now, yeah, here it is. By the way, how much I love this keyboard, you won't believe it, but it's almost as thick as my current laptop, so I'm not complaining, right? This is the 1995 equivalent of an Xcode download right here. This is the standard edition for hobbyists, the cheap one for 249 Deutschmarks. The professional edition was even more expensive than that. Yeah, the 1990s Microsoft. You remember Microsoft? Anyone? Okay. So I found this on the back of the packaging. It's the German edition, obviously. Here's a fun detail. Apparently in the 1990s, we Germans called buttons Befehlsschaltflächen. So the text actually reads, with buttons like print report or quit, you can start or end an action. This is how you can create your own professional-looking toolbars. So actually, programming Visual Basic got me hooked on designing user interfaces. It was fascinating to me. I could build real programs with professional-looking Befehlsschaltflächen. And now, 20 years later, I'm making a living as a professional-looking apps making person. When I tell other people that I make apps, there are only two possible reactions. One of them is, oh, I see. Kind of like, sorry for you. The other one is, oh, I have a great idea for an app. It's like, you heard that before, okay. Thanks. So if anyone wants me to be more specific with my job title, I tell them this now. I say I'm a user interface typographer. What does that mean? It means I put text on buttons, on Befehlsschaltflächen. Or to be more specific, I specialize in typography for user interfaces. Typography is a pretty old profession. It means arranging text, giving text the appropriate shape for the purpose and the content and the audience. So why is this relevant for user interfaces? This is why it's important. Typography is everywhere. Text is everywhere. It's all over the place in user interfaces. It's not just another ingredient. It actually is the core of the user interface. Text is what makes these complex digital interfaces understandable and usable. Right? Imagine what happened if we removed the text from this. Or even from this. Suddenly it changed from hard to use to impossible to use just because we removed the text. And so the most important thing in user interface design is actually the text. And typography is user interface design for text. The problem is most people don't see the text. They see the meaning behind the text. Because that's how text works. That's how reading works. Most people don't notice the shape. They only notice the shape of text when it's very hard to read, or if they have the feeling that something's wrong and they can't quite put their finger on it. So that's why there are people who specialize in this, and they're called typographers, and they can actually see the shape and not just the G behind it, not just the meaning. It's only a few years old what we're doing in here. It's user interface design, programming, that's all kind of new stuff. And typography has been around for centuries, and there's an evolution, iteration, experience, and knowledge, and something we can all learn from this and put into our user interfaces. So why is it that traditional typographers have avoided designing for screens for the past 20 years? You know, you don't have the team like 10 developers, 10 designers, 10 typographers for some reason. Why didn't the best typographers switch from paper to screens 20 years ago? I believe that typographers were shocked when they first saw these websites. They were like, whoa, this looks like graphic design hadn't even been invented yet in 1994. This is the first Microsoft website. And who can blame the typographers for believing that they could never do anything as beautiful as paper typography? And then, of course, you don't want to read Harry Potter on this blurry, flickering monitor on a computer tisch. I think it's computer desk in English. And, of course, the book as a reading interface is way better than the thing on the left. But now we have these devices, so when we just talk about text and reading on screens, we should actually be talking about this thing on the right that is, you know, has a better quality in some cases than books. And we should start treating it as a first-class reading platform, not just typographers. We should all think about it as a reading platform. Because what people do on the subway when you see people fiddling with their phones, they're either playing a game or reading something. So what is it exactly that a typographer does? Pick fonts all day, call it a day? No, not really. Making text easy to process for human eyes and human brains. Sounds kind of familiar. That's what we are doing in user interface design, and typography has been doing that for centuries. So to introduce you to the topic in general, let's talk about numbers, number formatting. There are so many apps and services around numbers, but you know, financial apps and stuff. But in most of the apps I've seen, the numbers are hard to read, and that's insane because when you're making a financial app, for example, you're actually making a number viewing app. This is the uninspired way of, from my German bank's website, of an example of how not to do it. There's no love in this design. It's really sad. There's an S for the negative numbers. The only German bookkeepers understand that it's saldo, and it's a negative number. Look at this 3-pixel misalignment. That really drives me crazy. So a few years ago, I worked on a banking application for the German market called Money Money. Yeah, oh, thank you. This is the first time this ever happened at a conference for this product. Weird people. This is the original design from 2011, and UI fashion has obviously moved on. Textures and shadows are now no longer en vogue, but typography is timeless. So let me just show you how much thought we put into formatting the numbers here. This is, you know, what the bank does, maybe. Or if it comes straight from the database, that's the number you kind of get in your programming language. And this is what my bank does here. So they add the German decimal separator, the comma instead of the period, and then they append an S, and then they call it a day. So let's get rid of the S and add a minus. And as you probably know, or maybe not, this is not a minus, this is a hyphen. This is a proper minus. And the other one is only for programming and for, you know, hyphen. It even has a different Unicode. There's you know, let's add a 1,000 separator. In German, that's a period. And in the US, you would do it differently, but that's something that the operating system does for you. So the correct locale, you just apply it to the number, and then you have the correctly localized version. How about we make the currency a little smaller? Because it's always there, and it's going to be the same for all my numbers. I only have euros. And I'm not really happy with the font choice, because Helvetica is kind of hard to read. So let's use this typeface called Novel. It has more open shapes that are easier to read. Those serifs on the small version are a little too fragile, so let's add the sans serif version of that typeface for the currency, make it a little bolder, emphasize the important part and make it bolder too, and also maybe mute the parts that are not so interesting. Now you say that's a lot of formatting, right? Wait, I'm not finished. Here is more. So let's scoot this up a little bit. And then a little more tracking for the currency, a little more tracking for the number itself. And now I'm happy. Now I can finally read this properly. I think it was worth the extra effort. By the way, some banks and some financial applications do this, but the plus actually doesn't help because the intentions are good, but leaving out the plus actually emphasizes the difference better. And also, there's a thing called red-green blindness, color blindness, so not a good idea. And again, this is nothing spectacular. This is just typografisches Handwerk. This is typographic craftsmanship. I love reading Wikipedia. Here's another example. Do you guys read Wikipedia? Probably. Everyone does, right? Yeah, everyone. I read it too much, way too much. And the typography is really not that great. You know, you start over there on the left. Oh, this looks horrible on the wall. Anyway, there's actual text on that slide. But still, 3 meters or 5 meters of line length are not good to read, because over here, when you end up at the end of that line, it takes a long time to travel back to the next line. And I mostly read Wikipedia on my iPhone and my iPad, so I don't read it much on the computer anyway. And the website is not that great. The app, the official app, doesn't really make me happy, so I decided to build the Wikipedia reading app of my dreams. It's called V. V, because in German we say Wikipedia, so V for Wikipedia is what it's called. And my goal was to create a Wikipedia reader app that has the best possible reading experience on all of these devices. Yes, even the one on the left over there. Showcase for good typography with no excuses for bad typography. Let me show you how it looks. So when you open the app, you can see what articles are currently popular on Wikipedia. That's just the number of views. You can, of course, also search for articles like Friedrich Schiller. Open the table of contents, maybe. I'll scroll down a little bit. Open the table of contents, jump to a location within the text, zoom a picture. But my favorite feature is actually that the text is nice to read, which is not the case for many reading apps on the App Store. And of course, good typography starts with a good typeface, and it's especially important when you make a long-form reading app, right? Obviously. But my process for the whole app design was quite different from how things are normally done in the industry, I think. I don't know, probably. You tell me afterwards. Because the fonts I would use, the typefaces I would use, were one of the first things I decided on when designing the app. And you could say I had a typography-driven design process or development process. And every aspect of the app was considered from a typographer's point of view, and the design and the development happened at the same time, which was, there was no planning involved because it was just me, which is kind of helpful sometimes to get a better result than with 20 people or 50 people arguing. And since releasing, I've been constantly tweaking the app and improving typographic details, like, for example, added a night mode. And it does sound stupid, but reading a bit of Wikipedia on your wrist can be quite nice if it's done right, especially in combination with handoff, so you can continue reading on your phone. I have 12 quality fonts in my app, 4 styles of Diogenes, commercial font, 4 styles of Comet for like secondary stuff, tables, UI controls. I have 4 styles of Camingo Code, pretty nice free monospace font that I use for coding as well. Highly recommended. And, sorry, no, it's showing, yeah. And choosing typefaces is important and good, but choosing a typeface is just the beginning. It's like picking the colors for a painting. For example, a good body text reading experience is not just the typeface or the font, it's also the text size, the horizontal rhythm, the line length, and the vertical rhythm. And these are the 4 magic square parameters. That's what German typographers call that, magisches Quadrat, for Lesetypography. And it's just 4 parameters that you have to get right. It sounds easy. It's really quick, I'll show you. This is unformatted text, or rather it's not unformatted text, it's just badly formatted. Let's choose a typeface and then adjust the text size, the horizontal rhythm, the line length, the vertical rhythm, and you're done. Normally it takes longer than this, but this is, if you get all of these things right for reading, then, and plus the font choice, of course, then you have a good reading experience. And it's nothing spectacular, again, it's just typographic craftsmanship, and it's also something that can be easily documented in mock-ups and design specs. But every typographer wants full control of every detail, so not just, you know, the stuff I've just shown, but also the stuff they used to, the things they used to do manually in traditional typesetting. So let's say content-dependent layout optimizations, because you don't know what content you're going to get and you want to react to how much text there is on one line and how much there is on the next. There are typographic tweaks that the typographer might want to do. I'm going to show you examples for this in a minute. And also neat line breaks, like really at the right places, the right line breaks, especially in headlines. These things are really hard to put into a design spec because they're actually rules. These typographic requirements are rules, so they're inherently algorithms. And the typography lives in the code behind the surface. That's what I tell my typographer and designer friends. It's not, you know, the rules for typography sit in the code. I'm going to show you a few examples from my app. This is how the title, the header looks like. Actually, that's not what it looks like, because that's what it would look like if I didn't care. So I add the line break in the right place. How do I do this? I always add a line break after a colon in every title. To make it look a little nicer, I put everything after the colon into an italic font. And then I do this. I don't know if you can see it. I'm going to zoom in a little. So my algorithm also adds a tiny little hair space before the colon, because that's what you do. And of course, it's, you know, I don't have to tell you how to do this stuff, but there's a Unicode for this thin space. It's not a lot of work, but you know, you have to know how to do these things, and you have to know that you do them in the first place. So the beautiful thing is, once I've written this code, it of course can handle all articles, all other articles on Wikipedia automatically, even in languages that I don't read. I'm going to show you another example, a more complex one. What do we do with long titles like this that don't fit the header? Luckily, there's a pattern that I saw in these article titles that a lot of them start with list of or a localized version of list of, and they end with something in brackets. So I could just grab them with here's a simplified version of the regular expression I use. You could just use a regular expression and then parse these parts and then find all of these parts in all Wikipedia articles and format them the way I want it. So instead of this, I get this, which looks nicer. And the beauty is, again, write the code once, apply it to all millions and billions of articles. That's how I, you know, tell my designer friends. You guys know that. So this is the location search. You can find out what places are around here. But what I actually wanted to show you here is this detail. Because, of course, I use a proper thin space here, because that's what you do. You put a thin space between the number and the unit. And of course, it's not rocket science. This is what it looks like in Swift, one line of code. But you need to know about it, how to do it, in order to make it, to do it. So I don't think many apps really pay attention to this stuff, but many books do. All traditional books do, by the way. So this stuff is called microtypography, and this is, you know, using the right spaces, but a lot of other things as well. And I'm obsessed with microtypography. So let's have a look at a couple of fun, pretty famous, familiar iOS apps of Spiegel Online, The Guardian, and the BBC. These are random choices. I could have picked many others. They have wrong double quotation marks, they have wrong single quotation marks, and they have wrong apostrophes. This would never happen in printed newspapers. Buy any newspaper now, printed one, you will never find this, because these are not correct quotation marks. It's my mission to explain this to my generation and to the younger generation. These are not correct. These are the correct ones for English, and also these are the correct ones for German. And on the upper right, that's what they use in Finland, and right in the middle, Poland. Bottom right, Switzerland. There are so many great local traditions, and still people use this. You know, it triggers a syntax error in my brain because it's the same thing. Seriously, I can't read anything that has these. I don't think you should clap for that. That's kind of, thank you. And that's just because the correct ones are not on the keyboard. You need complicated keyboard shortcuts to type them correctly. And also for the apostrophe, this one is the correct one, only this one. So why is that? I think the reason is that our modern laptops are actually just a typewriter attached to a very fancy computer in a small package, because the keyboard we have now is almost the same as the one we had 150 years ago. And typewriters had identical opening and closing quotes because there was a limited space on the keyboard. Everything you could save there was valuable. But what's going on over there? What's going on in the upper left? There's a crazy B instead of the 1. And also, there's no 0. So how did people then write letters without 1s and 0s? That was before computers, maybe that's why. But this is how you did it. You just typed a lowercase l to get a 1, and you typed an uppercase 0 to get O to get a 0. And that was because there were hammers in these things, and they had to, you couldn't have an infinite amount of hammers. So it was an engineering-driven design decision 150 years ago. I imagine we would still have to press the lowercase l to get a 1. That's how I feel about the typewriter quotation marks on this device. So let's look at the quotation marks on Wikipedia. Of course, they're all wrong. If you fix them, by the way, they will fix them back to the wrong ones, because it's a convention. Convention, not convention. But of course, I did something about this, because I wouldn't be able to ship my app with this. So this is what it looks like in my app, way better. Did I edit every single article? No, I couldn't, because they wouldn't let me. And so I made a piece of code that actually fixes the quotes and apostrophes on page load on the fly. And I even made a cute logo for it. It's called Typographizer. And it's a Swift module that takes dumb quotes and eats them and then spits out the correct ones. And the good news is you can put it in your apps too and make them happy, because it's on GitHub. I'll show you in a minute. And it will also use the correct localized versions for the language code you pass in. So you get the nice German ones, or even complicated stuff like this. Doesn't always work, but if you're a computer scientist, this is the first time I've written a tokenizer. You can just get this stuff on, this is how you use it. Typographized language, done. It works on all Apple platforms. And if you're a computer scientist, you can download everything, rewrite it, and then file a pull request, and I'll be happy to, replace it with your 100 times or 8,000 times faster version of my Swift code. This thing also comes with testing, little macOS testing app, and it ignores everything in HTML, so you can throw HTML at it and not break anything, code blocks, because code is the context where it's actually legal to have these. The documentation is almost as long as the source code. I kind of got carried away with this, explaining, all the different language versions, and but it's actually just one line of code for you if you download it. I even got this fancy domain. I don't know why it wasn't taken. Typographizer.com. And there's really no excuse. If we have a Swift app and that shows typewriter quotes, there's no excuse for it anymore. As I said, I love neat line breaks. And if I look at this, it really hurts my eyes to see a very long line and then a stray word in the next line. So what I want to do is add line breaks before the second last word, sometimes. So this is something a traditional typographer would do manually in a printed book. I just fixed it with a little bit of code. Excuse the German slide here, but it doesn't really matter for the sake. How I do it is I add a non-breaking space between the second last and the last word. My designer friends always think I'm shitting them when I show them that this is actually is a thing in computer science, because just regex looks like I just banged my head on the keyboard, which I do sometimes when I write regex, right? So what this thing does is it looks if the last word is between 1 and 16 characters, and the second last is between 1 and 8 characters, and only then does it add a non-breaking space. The last feature I'd like to show off here is the inline search. I swapped the arrangement of controls on the search bar, by the way. It's the other way around in Safari, and it drives me crazy, because you want to have if you're right-handed, you want to have the up and down arrows on the right and the destructive action on the left. But anyway, this is not what I wanted to show. I wanted to talk about the numbers here, because I don't use the lining standard figures numbers included in this font, but I used smaller numbers that fit better in the context. But where did I get these numbers? It turns out that in many commercial, that means paid for fonts, not Google free fonts, that you get a variety of different stylistic alternatives in the font. They're all within that font. And in order to get them out, all you have to do is switch a toggle in the font for a certain feature. So, for example, if I wanted the ones on the bottom, I would switch on small caps and monospace figures, because I want them to be to have equal width. And then what I get is this, and it's pretty easy, straightforward to do in Swift. But I don't think we should dive into the code now. You just watch the 2016 WWDC session on typography. It's great, and it tells you all about the UI font descriptor and UI font feature type identifier key and all that stuff. I think it's time to stop thinking of design as something that's isolated from development. I'm really tired of this discussion. It is already happening in UI design that designers build prototypes with code. And I believe that typography, design as well, but especially typography, has to happen at all of these stages. As I've just shown you, it's not possible to specify all this beforehand in a mock-up and draw pictures of it in Sketch. And students still often ask me, do I really have to learn how to code if I just want to design beautiful things? Then I tell them, imagine you had designed this button, and the developer comes back with this, saying, it's blue, it has a drop shadow, Arial font, just what you requested, and now I'm going to leave. And then you can either be the designer who starts begging, or you can just fix it. Right? Thank you. But it's not just about fixing production code that's, that was different in the mock-up. It's also that designing with code is inspiring, and designing with code is necessary for good design, for good typography, and for better apps. Thank you. I apologize for this cliche slide, but I do have one more thing. I think I can pull this off at an iOS development thing. So I love the Wikipedia API. It's wonderful. I had a lot of fun figuring out how it works. And seriously, it did take a lot of time to figure it out. And I got kind of frustrated many times, and I did it wrong in many ways. And it took like 2 years overall now to finally have it in place. And today I'm open sourcing my apps complete Wikipedia API client. You can also download this, rewrite it, and then submit a pull request, because I'm not a computer scientist. But it does everything my app does, and the app works and sells pretty well. So it does all these things for you: download articles, search, geo search, most read articles. Thanks. And you can get it here. And I'm just waiting for Wikipedia's lawyer to tell me not to use their name in my product. But it's not a product, it's MIT license, so it's free. And open source and totally in the spirit of the community. So to test the thing in a brand new app, I've started building my own tvOS version from scratch, just to try my own API, because I want to test what I'm giving other people to work with. If you want to beat me to market, download it tonight and get started, but I'm not really sure if I actually want to be in that market. I don't know. I don't know if you guys have any experience with tvOS, but we'll see. So, thank you.
Thanks so much, Frank. That is tremendous.
We have some time left, right? We have 4 minutes left.
Oh my gosh. Amazing. Do we have any, thank you so much, Frank. Do we have any questions for Frank?
No, there is no Android version of it. That's usually the first Q&A question I get.
Yeah,
I'm sorry. You know why.
I'm delighted there's...
Because it's twice the amount of work if you do it right.
Yeah, that's true. That's true.
I'm not going to say anything in public about this Android topic.
Well,
I've said enough on this. Any questions?
Hi, thank you for a great talk.
Hi.
I was just wondering if you can recommend
so.
any resources if someone wanted to dig deeper into this topic.
Into typography.
Yeah, and like
I have a reading list on my website. It's hidden, but I can put it on Twitter later, which I use for my students to get started on typography. There's plenty of resources, a lot of traditional ones, a lot of new stuff, but still, it seems to be like a pretty new field, but it's actually not, as I've shown you. It's old stuff that we're just rediscovering.
How's it going? Andreas. Hi.
Hi. Yeah.
Okay, so
okay.
Do you support dynamic type?
Sorry?
Do you support dynamic type?
Dynamic type. I like it, but I don't use it in this app.
Why?
You mean variable fonts?
Yes, variable sizes.
Because they're not really ready for production, I think. They're still being, they're in spec. You mean that where you have interpolated masters along an axis? Maybe we should talk about this in the break, yeah.
How do you deal with limited space when the text grow? I mean, I'm thinking about localization. Something that is very short in English might be awfully long in some other language, is not gonna fit, or you have some devices,
so
6+, big screen,
so
4,
it's a good point, yeah. The only right answer I can give you is design everything in Finnish, then you have it covered, because it's the longest of all the languages. German is also pretty good. If you have to, replace bearbeiten with edit, that works, not the other way around. I think time's up. Thanks.
So our next speaker is amazing. He runs marathons, but not just any old marathon. You're probably thinking, oh, I could probably run a marathon. Andreas ran a marathon in Egypt through the Valley of the Kings. And he downplays the fact that he finished this marathon by saying, oh, I finished number 14 out of 23, so I'm not really up there near the top. And I'm thinking, oh my God, I would have died long before I finished the marathon. So I hope you'll give Andreas a warm welcome. He's going to talk to us about reactive programming with React Native. Wait a minute, hang on. I have the wrong person. It is still Andreas, but I have the wrong talk. It's unsophisticated software development, which is even better, because this is something I can learn something from. Sorry about that.
Thank you. Hi, I'm Andreas Oetjen, and maybe I'm. Does it work? If I'm toggling around a little bit, that's because I had the great chance to spend the last week on a ship. What they don't tell you is that Taste. What they don't tell you is when you go onto the ship, you get seasick, and when you leave the ship, you get land sick. And everything is turning around a little bit, like if you were on a ship, a permanent earthquake or something like that. So I'm working ever since the last 20 years in large-scale software projects. When I started, it was a tiny large-scale project. It was about 30 developers in the mid-90s, running for about 12 years, the whole project. I was not there 12 years. Then the project became bigger. It was about 100 developers running for about 10 years until it was canceled because there was no outcome. And now for the last 15 years, I'm working in a project with about 250 developers. To give you an impression, what I'm talking about is about 50,000 C# files, 16,000 configuration files where you can configure your application and do everything. In fact, you can't do everything, because if you do anything wrong, you just don't get anything anymore. It just doesn't work. Yeah, several build scripts and a bunch of C, C++, JavaScript, Visual Basic, HTML, and so on files. So this is what I'm dealing with every day. And what caused all this number of files and configuration files is, I think, is the architecture. So in a project like these, there are architects who do nothing but architecture. Maybe they have coded when they were young, but they don't code anymore ever since the last 15 years or so. And one original statement was, our architecture has to last for the next 30 years. So we design our architecture to last for 30 years. That was in the beginning of this millennium. It was the time before all this multi-core stuff evolved. It was just we're getting more megahertz and gigahertz, and everything will just run faster. And so 10 years ago, there was a big boom because the processors didn't perform faster, not the single cores. They just got more cores, and the software was not ready for this. And in fact, it still isn't ready because it's such a large amount of code, you cannot refactor this to be multithreading. They try, but it doesn't work. So me and my colleagues, we're talking every day, and we just get mad about all this mess, because if you want to do anything, it takes you ages. Just to create a dialogue with a few buttons on a text field, I did it just half a year ago. It took me 1 week to get this dialogue into the system. So, oh, it's a little bit, it's my son, you can't see him. There's a principle that's called SOLID. Single responsibility, open in, and so on, Liskov. This is an architecture thing that you can implement, but as with everything, you can exaggerate this, and that's what they did. Also, this divide et impera, divide and rule. So to split up your application into smaller parts, and these parts will then do only their own thing, and so on. This works fine if you find an end to split up. But if you split it in 2 tiny parts, it just misbehaves, because nobody can oversee how they are connected anymore. And you find yourself in kind of unnecessary abstractions. So you have got base classes and base classes of base classes, and so on. You have got an interface flood. There's an interface for everything, an interface for factories and so on, just to get the possibility to extend something or to exchange something which is never done. So I would say 90% or 95% of all the interfaces have just one implementation. They don't even have test stubs or something that will be exchanged then to make it testable, because the architecture doesn't foresee unit testing. So we start to implement unit tests now, but it's very hard because everything is so interwoven, you cannot easily exchange parts of it, because they all require some kind of inter-process communication and so on. You have to mock everything, and it's very hard to do so. And the most annoying thing is these extension points. So in the code, you don't see anything. You don't even see the classes. You don't have any tools to help you, like ReSharper, to find any implementation, because this is done by the XML configuration files. So there's a set of configuration files which define which class will implement which thing, and you could exchange it at customer side or anywhere, which nobody does, because then it doesn't work anymore. You have to exchange everything, yeah. But it's, yeah, it will last for the next 30 years, I think, that nobody is going to exchange anything. Mission accomplished, yeah. You know. And what you get is something like this hourglass. An hourglass looks very easy. Just put sand into some kind of filter and wait until it disappears, and then you measure the time. On the other hand, there's a clock with all these gears and so on. This looks complicated, but the difference between those two is you can almost always calculate what the right clock does. You count the number of, I don't know the name, teeth of the gear, and see how they rotate and so on, and there's a spring, and it's all mathematically be describable. It can be easily be repaired, and so on. This is maybe complicated, but it's not complex. The people are doing this since the last 500 years. The hourglass is not complicated, but it's complex. It's like having 50,000 files of code and being involved with a third of configuration files. Yeah? Everything might be very small and tiny, like a grain of sand, but you cannot calculate how they behave in masses. You can just see and let it flood through and say, oh, yeah, check the time, but if one little grain of sand misbehaves, you cannot calculate this. That's what's overconfiguration. Yeah, that's one of the most annoying things we deal with. It's meant to exchange something, to be flexible in somehow. But if you exaggerate this, then it gets very annoying. It's almost not debuggable. You have no tooling to help you. You can write your own tools, yeah, but this takes almost as long as the other developing the real software, or even longer. And the problem is, once you got the tools, then the configuration stuff might evolve. Then you have to adjust the tools to cope with this. And you cannot debug anything. Yeah? We start the application. You have to search for log files or something. You cannot see on the debugger why this class is now instantiated or not. What they also do is they invent new frameworks for database access or for multiprocessoring, even for multi-threading. They have their own frameworks to just to abstract this from what's well-tested and well-provided by some larger company. They always think, oh, well, that's not exactly what we need. We need something else. We might exchange the underlying database somehow, someday. So we just have an abstraction between and a layer with an own framework and so on. Has anybody of you written an application where the database has been exchanged 1 or 2 years later? Yeah? And it works fine? And did you have an abstraction between before? Yeah? Ah, there. Congratulations. Yeah. I've never seen such a project. Yeah. You try to reinvent the wheel sometimes, or make it even better. A problem with creating your own frameworks, your own application servers and so on is you don't get any help from the outside. If you use something like JBoss or some other application server, you can just take a look at Stack Overflow, and somebody already had this problem. And if not, you just ask something, and you easily get an answer if your question was not too dumb. And it's not the business. So there's a little story I've read when I prepared this talk about a hammer, about a carpenter who wants to buy a hammer, and then he goes to the store and says, oh, we don't sell hammers. We have this kind of and that kind and that kind and that kind of hammers, not just hammers. What hammer do you want? Yeah, I want a, don't know, sledgehammer or something. The problem is we don't have this kind of hammer anymore because the people don't want special hammers. They want a universal hammer. Yeah, then sell me the universal hammer. We don't sell this universal hammer anymore because it's not good in every detail. So what we now sell is, or what we used to sell is, we sell a factory where you can create hammers. Yeah? And you just have to feed it with some resources and employees and so on, and then you get the hammers you want. Yeah, can I buy this factory? No, we don't sell this factory anymore because the people just don't want to create every hammer. They just want to create a special set of hammers, so we now sell a factory that creates hammers. Yeah, then I want to buy this factory. Now, the problem is that the people don't only want hammers, they want to have saws and meters and gauges and so on. So what you actually get is we sell a factory, a universal tool creating factory, where you can create a factory that creates a factory where you can create exactly the hammer that you want. And this is something that frameworks do for you. So you just have to do some configuration, and then you get exactly what you want, and nothing more, nothing less. And that's something that maybe some people are older have to cope with. It's exaggerated, but yeah, it's annoying. So now, from the abstraction a little bit more to the details, multi-threading. Multi-threading is a very good thing to split the execution code up to multiple cores. But sometimes, so I'm reading on Stack Overflow and trying to help some people. And sometimes I get the idea that multi-threading, especially also in Swift with all this Grand Central Dispatch stuff, is way too easy to use. So that people just write the code, have some multi-threading, and then they wonder why the text field is not updated. And then you write for the 1000th time that you have to do this on the main thread and not an arbitrary thread. Also, I think what's coming up in Swift soon will be something like futures and promises, where you return a value that will be calculated in some future. Not now, but in the future. And then when it's finished, you can get the real value from this stuff. There are some implementations in Swift already on GitHub, but I think it will make it to the language itself soon. It's also something that's very easy to use and easy to be misused. Yeah? Because multi-threading is kind of evil. You have to think of many things before you use multi-threading. So you won't give your little boy child or girl child a chainsaw in its hand because it can do anything. You start with a knife, maybe a sharp knife, where it can hurt itself, but it won't be such a big disaster like with a chainsaw. Yeah? When I started programming, it was the C and the C++ agents where multithreading was very hard to understand. You have to think of everything and so on. And yeah, you would not easily do multithreading if you can avoid it. So there you get an idea what happens on behind. With all this future promises stuff, I think sometimes it's too easy for the people to do it. And they write very nice to see stuff that doesn't run in the long term. And it's also hard to test. In C#, there's something that's called LINQ, Language Integrated Query, where instead of writing for loops and so on, you can write some SQL-like code to analyze your data and to create something new out of it. Yeah, from a set, join another set where something equals, where something contains a name and so on, and then we create a new object that contains data from this query, let's say. And you can also, with LINQ, you can return collections or enumerations that will be executed on demand. So you return a kind of list or an enumeration, and only at the moment when you access elements from it, they will be calculated. And this also works with link for SQL and link for entities, where you got database connections, database reads here. So you distribute all your enumeration through the whole application, and you don't know when they will be executed. And if you do this in a large project, then you get database logs where you don't expect them, and where you don't can handle them. And even worse, this typically happens at customer side, because the customer has different data than you have, so it behaves a little bit different. Then there are some easy constructs to use in link, like any, to check if there is any object in some list and then do anything. We had this. We had an iteration about medical images with a link statement, and it should check if there was any data in a list. And this iteration took 30 seconds to run, and it produced and we exchanged this any call with a count call. So we checked if the count was 0. It's almost the same as any does. The drawback of count is it counts everything first. So it may take longer. One would think it takes longer. But if in this special situation, we had the case that it was almost always empty. And what any does is it creates a new enumeration that's empty, and then throws it away, disposes it. So the most runtime of this 30 seconds was just the garbage collector cleaning up all the enumerators that he created temporarily just to check if that was empty. And if you look at Stack Overflow, everybody says don't use count, use any. And I tell you, check first if any is good, because if any almost always returns 0, because almost every time your collection is empty, you should maybe use count. Then there are some tricks, operator overloading, customer operators. You should also take care if when using those operators. Here, in the example, there's this tilde greater than, which will execute the left-hand side in a background thread, and the right-hand side, the return value, will be handed to the right-hand block, which then will be executed in the main thread. There's a link, Swift threading, which is nice to read, but if you don't know this syntax, if you're new in the project, then you don't know what happens here. If you have a problem here, nobody can help you on Stack Overflow. If you have to do something to debug, maybe you don't find it at the right place. So you have to take care not to do too much tricks in your code just to save a little bit of coding. Then there was something like, so in Objective-C, some people did this method swizzling, associated objects to just do some funny stuff, let's say. This, when Swift evolved, this works with several classes, with several others not. So I remember a question on Stack Overflow where somebody wanted to associate something with an index path, which you get when you do some cell operations on table views. And he wanted, they associated objects with this index path. And in Swift, it doesn't work anymore because the index path is a struct, and the struct doesn't have it cannot associate any object anymore. Yeah, but you don't see it. The code still works. It returns false, but nobody checks the return value here. You would explicitly use NS index path in Swift, then it works, but nobody knows how long it works. So if your code relies on tricks like these, like method splitting associated objects, you might get problems in the future if you're too sophisticated. Sometimes it's even better to use simple algorithms. I think everybody can understand what this does. It's just a for loop about every element and just multiplies it with 2. And now the second for loop just adds them up. There's also a nice way. Now, typically nowadays we would do it this way, like some mapping and reduce. It sounds easier, it's a lot less to write, but this simple example is easy to read. But if you get something like the link statement a few slides before, if it gets too complicated, I think it's much harder to read this. This is a bad example because, in fact, the right example is easier. But it's just to demonstrate is if the right thing gets more complicated, maybe it's easier to write a simple, unsophisticated for loop, which is nested or somewhere, where you can set breakpoints at the correct point, and so on. We can step through. Maybe if you can just do this. If you have small collections, where you know it only contains 3 elements, maybe it's better to write this code instead of a for loop because it's easier to read. And the compiler, if it's clever, will create some code like this. If it's not clever, it will create a loop, and then you get problems with modern CPUs because all these jumps in there, there's the jump prediction that doesn't work fine, and so on. This code runs way faster if the compiler is not clever. Yeah. And just here, this is C. Does anybody know what this does? Yeah, string copy. So I think nobody began with C here from you, because this is a very typical idiom. Everybody who writes C should have seen this. It just copies a string to another string. Hopefully it's 0 terminated. So what to say? Mixed emotions. I've got a mixed feeling about clever programming. It always looks good, and when Swift evolved some years ago, you could see many blogs where the people did many clever things with functional programming and so on, which unfortunately didn't work with Swift 2 and Swift 3 anymore, because it was way too clever, or the language just evolved in a way they didn't foresee. So if you try to be too clever, maybe your code won't work anymore anyhow in some future. Hopefully it will, but yeah, you might get problems. And I only can wish to everyone to just stay small. Don't join large-scale projects. Yeah? I do this large scaling I do about 80 or 90% of the time. The rest of the time I do some Swift stuff for friends of mine who run their own companies. I try to help them, and this is just holidays for me. Yeah, small project where you can have an overlook of everything. There's no configuration and so on. So that's it. I don't know, way too fast, huh? Any questions?
Thank you so much, Andreas. Yeah, that was fantastic. We're running a little bit short on time, so if you have any questions for Andreas, maybe we can catch him in the coffee break. Actually, I'll call you in a second. And this time I'll get the right presentation. So our next speaker is from Ireland, and he's a photographer who apparently has been out in the woods of Ireland looking for leprechauns, but he actually is a React Native programmer, not like Andreas. So I'd like to welcome. Wait a minute.
Name's Harry.
Yeah. It's Harry. I'd like to welcome Harry to the stage.
Okay.
Is it all working? I hope it is. Okay. So please give a warm welcome to Harry.
There we go. Hey everyone, my name's Harry Tormey, and today I'm going to be giving a talk entitled An iOS Developer's Take on React Native. So before I get into my talk, I'm going to give you a little bit of background information about me and my career so you can better understand my perspective when I talk to you today about React Native. So first and foremost, as you might have guessed from my accent and the warm introduction I received, I am Irish, but I didn't actually come here today from the green hills of Ireland, no. I flew all the way from San Francisco in California, where I've been living for the last 10 years. Now, for most of that time, I've been blessed. I've been working as a mobile software engineer. I got my start working at some random mobile startups that don't exist anymore, so you probably haven't heard of them, mainly doing iOS. Hello? Native development. Sorry. Hello? It's working again. There's leprechauns eating at my cabling or something like that. Yeah, so anyway, I was working at a bunch of mobile startups doing native development, a little bit of HTML5, and then I went on to work at some big companies. I worked at Apple for the guts of 2 years in the core audio team, mainly doing Objective-C with a little bit of C++. I then moved on to Facebook, where I worked for 2 years in the main Facebook iOS app on 2 teams, the commerce team and the search team, mainly doing Objective-C++, mainly working with a framework inspired by React called Component Kit. I did do a bit of React development there, but absolutely no React Native. So fast forward to today, and what do? I work as a consultant/contractor who specializes in mobile, mainly iOS, and most pertinent to this talk today, React Native. Now, at this point in my talk, I want to stress that I am not a React Native evangelist. Hallelujah. The reason why I kind of rolled out my career was to kind of stress the native emphasis of my background. I'm not a web guy who's coming here to try and sell you that you should give up Swift and switch over to React Native. Heaven forbid you do that. What I'm going to do with this talk today is I'm going to explain how React Native works and clear up any misconceptions you might have about how it's similar or different to other frameworks that often get conflated with React Native. After I finish explaining what React Native actually does, I'm then going to take on the role of the defense and make the case to you for React Native. I'm then, after that, going to take on the role of the prosecution and make the case against React Native. And then at the very end, in case you're confused, I'm going to leave you with some heuristics that you might find useful if you're trying to decide whether React Native is a good fit for you or your organization. So now that that's out of the way, I want to conduct an informal survey. If you have written an app using React Native ever, could you put your hands up, please? Oh, wow, I'm scared now. Okay, put your hands down. If you have written an app using a framework called Cordova, could you put your hands up, please? Ooh, I think there's more Cordova developers here. Okay. So how does React Native actually work? Well, a good place to find the answer to that question would be the React Native developers docs. And if you go there, you'll see the following line. React Native lets you build mobile apps using only JavaScript. JavaScript. Now, I talk to a lot of native developers, and that image just conjures something in their mind. And that image is hybrid mobile app framework. So a question that you might be asking here, seeing as the vast majority of you haven't done anything with React Native, is React Native yet another hybrid mobile app framework? And the answer to that question, no. But I think because this conflated idea of React Native being a hybrid mobile app framework often occurs, it's worth exploring what a hybrid mobile app framework is, and more importantly, why React Native is a totally different beast from that. Okay, so what is a hybrid mobile app framework? Harry, we've never done this before. We don't know what it is. Can you explain it? Yes. Here's a picture of a hybrid mobile app framework. No, I'm only joking. A hybrid mobile app framework is basically a native container that wraps a web page, some CSS, JavaScript, HTML, and that web page is basically the user interface for your app. It basically allows you to take this web page and stick it into the Google Play Store or the Apple App Store. That's kind of what it is. So, if you're familiar with the history of mobile development, these hybrid mobile app frameworks tend to have a bad reputation, both among developers and consumers. Now, because these hybrid app mobile frameworks are often conflated with React Native, I think we should explore why. So why do hybrid mobile apps have a bad reputation? Well, in my opinion, it's largely for two reasons, which I'm going to go into right now. The first one is that they use web views. Now, if you think about that for a moment, if you use a web view to display your user interface, fundamentally, you have a middleman that sits between you, the developer, and the underlying rendering pipeline and memory management system of the device that you're writing for. You can't stick a UI collection view or UI table view in the middle of a web view. It's either a web view or native code. And that fundamentally constrains your ability to create a rich, native-like user experience. So I think that's a big reason why they kind of suck. The second thing is, and going back through my career, the last time that I did web development before Facebook and doing React Native stuff was about 2011. And that's about the time that hybrid mobile app frameworks were really in vogue, prior to Facebook and LinkedIn abandoning them for native, the true religion, by the way. So why did web development used to suck? What was it about it that made it really crappy? Well, in my opinion, it was basically because the abstractions that you were forced to use back in the day, like jQuery and a bunch of HTML and CSS that had to work with all of these weird desktop browsers that had these problems, were very poor if you were coming from a world like native iOS development where you had view controllers with a life cycle and you had model view controller and other kind of nice design patterns that made your software kind of awesome to work with. So if you were a native developer doing web development back in the day, it seemed like crazy town. The good news is that web development has improved a lot in the last 5 or 6 years. And the story of React Native and why you should keep an open mind about it has a lot to do with the things that have improved web development. So why has web development improved? Well, in my opinion, it's kind of down to 3 things. And the first one of those things isn't just specific to JavaScript. It's the rise in popularity of functional programming. And specifically, the impact that this has had in the way that web and other front-end frameworks are designed. React is a functional framework. It uses a declarative way of describing UIs, and it takes data in a unidirectional fashion. The other thing that you might not be aware of that's kind of gotten really big in the JavaScript world is transpilers, language-to-language compilers. So originally, these were kind of developed because new versions of JavaScript would come out, ES6 and ES7. Developers would obviously want to use them because old JavaScript kind of sucks. It didn't have classes and promises and all that kind of stuff. But how are you to get them into production where lots of people are on crappy old browsers? Well, the answer to that is you transpile the language down to a version that those browsers support. A side effect of this, though, was that transpilers allow JavaScript developers to bolt on features that weren't present present in the language. So you can actually have type checking in JavaScript now via Flow or TypeScript. You can also inline markup languages like JSX alongside your JavaScript. So the tool chain that JavaScript developers have these days is much more advanced than the ones that were present back in 2011. The other thing is that JavaScript as a language now has stuff like classes and promises and much nicer abstractions. So in my opinion, it kind of sucks less than it used to do. Okay, so what is React? Well, React is kind of like the thing that React Native is built on top of, so we better understand this in order to understand React Native. So if I was to use one line to express what React is, it's basically that your UI is a function of your data. And you're like, Harry, that's very abstract. Can you be more specific and give us a concrete example? Well, let's consider a really dead simple user interface. A label that displays a count, and a button that when you push it, updates the count. Well, if you were expressing that, it would be the UI is a function of the count, the data. But what does that look like in code? Now, I'm going to pause for a moment, because there's a lot to unpack here. This is React web code. Now, the stuff below the return statement there that looks like HTML, that is not actually HTML. That is JSX. The stuff that's above there, where it's getting the count, that is actually from the data store that's associated with this React component. Keep that in your head for a second. So this is not HTML. This is what's known as the virtual document model. This is a description of the UI that React is then going to take and translate into HTML and CSS, which your web browser will render. This is an important point to note. So how do you update state? This is a fundamental question for all front-end developers. So if you were to think about this app from the point of view of an Android developer or an Objective-C developer or an old-school JavaScript developer, you'd basically get some kind of reference to that counter, and you'd set a value on it. With React, you don't do that. How do you update state with React? Well, you use something that's called setState. So this is a zoomed-out version of the React component that I showed you earlier. And as you can see, it is a class. It extends components. And as an aside, components are kind of roughly analogous to view controllers. They have lifecycle functions and so on. And basically, what's happening here is we're wiring up a setState call to when you click on the button. So what's going to happen when you hit this setState? Well, the setState increments the data. The data, the store, causes a new virtual DOM to be rendered or created. React, under the hood, diffs the tree that represents the old UI with the new one and handles basically updating all of this stuff for you. It only blitzes to the screen the stuff that has actually changed. So here is a model of this with trees, in case you like visualizing it like that. So how does React Native work? Why is all this relevant to me? Well, just as React for the web takes your description of the UI and converts it into HTML and CSS, React Native takes your description of the UI and converts it into native components for the platform that you're targeting. It does not use a web view. It converts it into, on iOS, UI views, scroll views, and so on and so forth. So you're not actually going through a web view. This is fundamentally a big change because it allows you to wrap and embed UI collection views. And if you run into performance issues, you have a get-out-of-jail-free card, unlike with hybrid mobile app frameworks, which don't. So let's revisit the code again. So this is what that counter app looks like in React Web. In React Native, it's basically exactly the same thing, except you're using views and text and buttons, React Native components. So the same ideas and the same constructs still apply. And as you can see, and if you're familiar with old-school jQuery, in my opinion, this is a much nicer set of abstractions to work with and is much closer to what you would be used to if you were a native Android or iOS developer. OK, so let's take a step back and look at this from a system point of view so you have a better understanding of how this actually works under the hood. So in React Native, there's kind of like two realms. There's the native realm that does all the heavy lifting, and the JavaScript realm that basically is where all your business logic is written. So if you tap a screen, or if a network timer event goes off or something like that, an event occurs in native. These events are then batched and serialized and passed across what's known as a bridge to JavaScript core, which is running in a separate thread. JavaScript core then processes these events, and React decides whether the screen needs to be updated or something else needs to be called. And this will result in basically native methods being called. And that gets serialized, passed across the bridge. And then React Native then updates the UI if it needs to in the native side. So again, a lot of this example I shamelessly listed from one of the React Native core developers' presentation. His name is Alexander Kotalarski. He's a really awesome developer. He has a talk entitled React Native Under the Hood, where he goes into this in a lot more detail. I highly recommend you check it out if you're interested in this sort of stuff. Okay, now the defense has taken the stand. What is the case for React Native? The first article of evidence I'm going to present is performance. Because when I started out with React Native for one of my clients, I was very skeptical about performance. I was worried that we were going to run into all sorts of issues with images. In fact, once you have an understanding of React Native and how it works under the hood and how it's different, you don't really have the performance issues that you think you will. So even though most of our app code is written in JavaScript, the UI of our app itself is completely native. The UI is manipulated exclusively on the main thread, but there can be others for background computation, sizing, and so on. React Native does most of the heavy lifting in this realm for us. In the JS realm, which on iOS is powered by JavaScript core, JavaScript is executed in its own separate thread by the JavaScript engine. Our business logic, which includes which views to display and how to style them, is usually implemented here. So where do performance bottlenecks tend to occur? Well, basically it's at the bridge. So all of React Native apps have code running in two realms. Variables defined in one realm can't be directly accessed by the other, so you need a bridge. This means that all communication between the two realms is done explicitly over this JavaScript bridge. Each realm by itself is blazingly fast. The performance bottleneck often occurs when we move from one realm to the other. In order to architect a performant React Native app, we have to keep in mind that we need to minimize passes over the bridge. So stuff like this can occur with like animations or gestures. But the good news is that it's not a problem. It's actually very easy to optimize so that you basically keep all of these animations on the native side without even having to dig into code. You can actually specify this quite easily in JavaScript. So again, to recap, React Native doesn't use web views. This is of massive significance for performance. It's easy to wrap native components. So if you want to basically do all of your layout as a collection view or whatever, you can stick that in the middle of a screen that's powered by React Native, no problem. Optimizing the React Native bridge is relatively easy, and other performance issues that you can run into are usually overdraw issues. I've run into a few of those, and they're usually a function of poor choices in third-party libraries or a lack of knowledge of the developer tools. They're generally been pretty easy for me to kind of optimize and get around. So how do you wrap native code? I'm not going to go into this too deeply, but like an Objective-C, you have a few different options. You can use macros to wrap functions. It supports emitting events. It supports callbacks. It supports promises. And it allows you to specify the thread that your native code runs on. In Swift, you don't have macros. You have to use modifiers, but all the other things in that list apply there. So here's a brief example. Basically, if you want to wrap some native code, you implement this interface, and then you wrap your functions like so in the following macros. Emitting events is also similar. You basically just have to call a delegate function in order to do that. And React Native sets all of that up under the hood. So in case you don't believe me and you want some more information, I actually wrote an article where I take a classically slow app, a big scrolling list of images of cats and random stuff, and I make it fast. I do most of this in JavaScript. There's a GitHub repo. You can check that out. But at the end of this article, there is a plot twist. And that plot twist is that I take the JavaScript image code, like the list code, and I move it over to native. It's Android. Sorry about that, guys. And I wrap it in a recycler view. The plot twist is you don't actually gain much performance from doing this, and in the article I kind of go into why this is the case. But again, I have loads of statistics, graphs, and all that kind of stuff there. It's worth checking out if you're interested in that. And if you follow me on Medium, I'm going to be writing more about this. Other great articles on performance, which you might want to check out, is the excellent work done by this guy at Wix called Tal Cole. He has, my favorite article by him is Moving Bound Animations to User Interactions at 60 frames per second. So he actually presents some problems that you can run into with the React Native bridge, and he shows you how, because animations are deterministic, you can actually express them in such a way that they'll be completely done on the native side without going back and forth over the bridge. Now, you can't really talk about performance without holding something in your hand, because a lot of the time, native developers want something that feels native, right? So this app here is made by Wix, and it uses a bunch of their open source libraries. You can download this from the Google Play Store or the Apple App Store now. It's called React Native Interactions. The source code of this is available on Wix's GitHub. It's really great to play with if you want some kind of solid proof that performance actually does feel good and the gestures are nice to use. Some other things I'm going to kind of touch on briefly is animations in React Native and how they work. The animations API is actually pretty nice. This is another thing that I was kind of worried about when I kind of got started with it. So this last image, let's explore how we do this. I'm not going to go into all the view code. I'm just going to show you a snippet. So again, this is a zoomed-in part of a React component. So component amount is kind of analogous to a view controller will appear. We're kicking off the animation once the component is ready to. And basically, this is a looping animation. What we're doing is we're taking the animated value, which is 0, and we're moving it to 1 with linear easing over 2 seconds. And then when it hits the end, we're going to loop back and start again. So in the render function, what we do is we basically take this moving value that's going to be passed down to it automatically by React, and we interpolate it over a couple of different ranges that relate to opacity, moving margins, text size, and rotating X. Those values are then passed down to the actual components that you saw moving back and forth earlier on. If you want to see more comprehensive demos of animations and play with some source code and read a really awesome article, check out Nadir Dabit's article on Medium and his GitHub, which lives at reactnativetraining.com. It's a really great article, and you can do a lot of stuff, like you can have animations in sequence, in parallel. It's a very sophisticated framework, and I've been very happy with it. Another case study of a top app that uses React Native in it is the Instagram app that's currently rewritten their saved images tab using React Native. They have a great case study about developer productivity and issues that they run into along the way. I highly recommend checking that out. Here's a video from the Instagram app of a React Native component that they use for basically their promoted posts. So again, this is being used in production in, apps that are really, really at scale, that are being used by hundreds of millions of people. Another great app that's completely written in React Native is the Facebook Groups app. I don't personally have the Facebook app installed on my phone, not because I hate Facebook. I love them. They were very nice to me when I worked there. But I'm a really easily distracted person. So I have the Facebook Groups app, and it's a pretty good app. It's all written in React Native. You guys should check it out if you're curious about that. Okay, the performance bit is out of the way. Hot reloading. Well, I made a very special video of what my day is like. So this is one of my clients, a medical marijuana app. They allow you to sign up for medical marijuana in the state of California. Unfortunately, not in Germany yet. But I'm going to just change this to be hi UIKonf instead of hi Harry. So the editor that I'm using here is Atom. Incidentally, you do get breakpoints and all of those kind of good things with React Native, and you can also use Xcode to debug the native parts of it. But this is basically what my day is like, and that's pretty awesome. As that app grows, that reload time doesn't get any slower. Also, you can do this on the device over Wi-Fi. You have a little shake interface, and you can hit reload, or you can wire it up in a way so that when you save the file, it gets pushed over to the device. So when you're working with designers, or if you're trying to kind of get some business log hashed out, this is much nicer than Playgrounds because you don't have to play around with setting up frameworks and stuff like that. So this probably is one of the biggest productivity wins that I get from it. So a topic that you're probably all really interested in is cross-platform apps. So my clientees, I wrote 2 apps with them, a driver app, which is kind of like Deliveroo for weed, and a consumer app where people can sign up for medical marijuana, both of which are only in California. So we also have a web team at Ease, and basically they're all really strong React developers, which is awesome. So we are able to use 100% of the API code for that. Some of the business logic, we haven't really tried to reuse the UI because I'm a little bit skeptical of some of the third-party libraries that allow you to share web and mobile. But we could probably reuse a lot more of that. On the consumer Android app, basically 90% of our code base is shared. The reason why it's not 100% is basically material design and different UI conventions on Android. We try to kind of keep our apps in line with what Android users would expect. But again, it's really, really great. On the driver app, we have some proprietary security and geolocation code that is native, and so that's why it's only 70% there. And whenever we have to touch that code, we have to do it for Android as well as iOS. It's also super easy to special case in the code by platform. We just have an isAndroid function, and if isAndroid, render the material design button. If is iOS, just do the other normal button. So over-the-air updates. They are pretty awesome. So JavaScript push is allowed by the App Store Terms of Services. You can't push native changes. That's not how React Native works. But it is easy to tie code pushes to binary versions. So for example, if you were trying to push some JavaScript that relied on some native code that wasn't in a version that was released, you can say only roll this out to version 1.x or whatever. It's also, in case you screw things up, really easy to roll back releases. And you can also do staged rollouts, like say roll out to 25% of our users on iOS or 25% of our users on Android or whatever. So JavaScript code push, scary, but kind of awesome. So team productivity. So I think that React Native really, really, really shines in shops that have a web team that are on React and whose Android and iOS developers are open-minded enough to try it out. So, on our team, we had a new girl start, Kyle, who was a React developer, and she was able to basically within a day rewrite part of our sign-up flows to match some changes that had been made on web. So for React web developers, this is really awesome. Also, while I was working with my client, all of the React web developers were able to give me help and code feedback. Erica, she's my awesome Android co-worker. She's a very strong engineer. She's also able to give me really, really, really great feedback, and we're able to review each other's diffs. And it's basically kind of double the amount of work that we can get done because we can basically work in the consumer app and the driver app in parallel, and we just have to kind of check each other's code at the end to make sure it works on Android or iOS and kind of tweak some things that might be broken along the way. Okay, Harry, this all sounds so awesome. This is we're ready to give up Swift. What is the case against React Native? Is there any problems with this? Is everything all sunshine and rainbows? And the answer is yes. There is issues with React Native. So ramp-up time, I think, is one of the biggest. This stuff doesn't come for free. This is not like a weekend project where you're learning a new framework. Basically, Erica, I've trained a few experienced Android engineers. So to give you an example of level, I have about 8 years mobile experience, and Erica has about 8 years mobile experience. She's worked at companies like Amazon and Walmart Labs and stuff like that. It took her about 1 to 3 months, like myself, to be writing good React Native code. Now, that's not because React is inherently really complicated or JavaScript is hard to learn. It's basically that in order to write a moderate to kind of slightly large application, you have to basically learn about the third-party ecosystem in the React Native world. So unlike iOS or Android, where right out of the gate, Google and Apple do an awesome job of giving you pretty much everything that you need to build a sophisticated app, basically with React Native, you get very few things. You have to rely very heavily on third-party libraries. So one of the things that I wanted to show in this presentation, but I had to cut due to time constraints, was how you manage basically data stores and state across multiple screens. So in order to do this, you'll probably need something like Redux. And Redux is a lecture all unto itself. It's really, really awesome. The guy who wrote it, Dan Abramov, is an amazing software engineer, but there's a whole ecosystem of stuff that you tack onto Redux, like Redux Sagas, Redux Thunks, and it's basically a lot to learn. So learning the right patterns, learning the correct third-party libraries to learn, that's a lot of work for a native developer, especially someone like me who's not a JavaScript aficionado. So web developers, the good news is they ramp up really quickly. They're able to be really productive, but they're going to hit a wall on native because they are not like really smart like you guys and able to understand Xcode and Android Studio and all of these performance issues, and they're not able to look under the hood at these React Native libraries to see if the Swift or iOS code is making dangerous assumptions about it. So you guys have a very valuable part to play on any cross-functional team that's doing this. So the next case in the prosecution is the third-party libraries. So there are 5 different nav stacks in use with React Native right now. There's one from Wix, there's one from Airbnb, there is React Router, there is React Native Flux, and then there's React Navigation. They all have different pros and cons, and they can all get you into a world of trouble if it's not quite what you're looking for. This is completely ridiculous, and I'm hoping that like over the next year or so, this resolves itself. The other problem with a lot of the third-party libraries is that if you thought that CocoaPods and Carthage had a quality problem, it's nothing compared to JavaScript. You really need to check every single thing that's not like sort of a brand name library that you should be using. I would also, give a shout out to Redux. It's totally awesome, but usually you don't just use Redux. You use something like Redux with Redux Thunk or Redux Sagas or Redux.js. Dude, there's like tons of white papers and stuff on this. It is a lot of work to learn and decide whether that's actually the right focus for your team. If you have web developers and you're thinking about React Native and they're familiar with React, they will be a lot of help in coming up to speed with the pros and cons of these. But again, this is part of why it takes 1 to 3 months to kind of ramp up with React Native. The other issue with React Native is when you go to update these third-party libraries. So every month, Facebook ships a new version of React Native. It's usually awesome. It usually has bug fixes. But every now and then, this will break third-party libraries. So keeping on top of this and dealing with basically all of these third-party libraries is a massive pain in the butt. And yeah. So the other thing is Android is buggy. I know we've made a few digs at Android, but React Native Android came out far after React Native iOS, and the level of stability really shows. So, generally a lot of the stuff that we did worked straight out of the box, but we did have to kind of fight with some third-party libraries and, manually kind of patch stuff ourselves to kind of get it over the foot. Some of these buggy issues are, related to Android just in general having to support a wider spectrum of devices and stuff like that, but some of them are just inexcusable. So for example, all of the JavaScript-based navigation stacks break accessibility on Android. So the reason the Facebook Groups app gets away with it is that it's displaying modals. It's not actually doing a deeply nested navigation stack. So my colleague Erica actually discovered this when we were doing an audit of our code. It totally sucked. She was really pissed off about it because at Walmart she had worked a lot with blind people. So again, if you're not willing to kind of dig up your, roll up your sleeves and dig into this, this may not be for you. That being said, it wasn't that much work for us to get our apps working on React Native Android. So I'm going to just leave this here and just say, all of these transpilers and all this stuff is great, but you guys have been learning Swift, and Swift is awesome. And some of you are just going to say, screw you, Harry, I'm not learning JavaScript. I looked at the 3 equals sign, and that was enough. I ran away screaming. And I'm not going to try and sell you on that. For many people, this is just going to be a deal breaker. Okay, so Harry, we're really confused. You've told us all this awesome stuff about React Native, and you've made a case against it. What should we do? Is there a simple table that we could use to help us make this decision? Yes, I stole this slide from one of React Native developer called Ryan from San Francisco. He gave this slide at a talk, and I thought it was great. I've updated a little bit. So it's basically maybe, maybe not. So if you know React, if you have lots of web developers but few mobile developers, if your design is brand focused, kind of like Airbnb's, not heavily native, you're not just doing apps for the Apple Watch, and you have cross-functional teams, or you're willing to invest in React Native, this 3-month ramp-up time, or you want over-the-air code updates, maybe React Native is for you. If you don't know JavaScript and React and you're coming at this from scratch, it's a lot of work. If you already have an iOS and Android team, maybe they're already really productive, and maybe bringing this in will cause a lot of politics. And this is something that I have a lot of hiring managers come up to me and talk to me about, and it's something that if you're trying to force this on a team will cause people to leave. There's a lot of politics in adopting something like React Native because essentially you're asking your mobile engineers to take a bet on their career in a technology they may not be happy about doing that with. So again, these are just some things for you to think about in the maybe, maybe not field based on what you're thinking. So again, like this is sort of a recap of like the pros and cons slide, like the talk that I've given so far. So, you know, I do consulting, contracting, and training. I'm actually teaching a React Native workshop June 4th in Chicago. I had hoped to kind of teach one here. If you guys want to see a more like complete React Native demo, come grab me after the talk. I also have a Medium blog at launchdoor.com, and my Twitter is htormey. And I just want to say, like, I love coming to Berlin, and I think this conference is absolutely awesome. I'd like to say thank you to Engin and Maxim and all the people who made this possible. This is an absolutely amazing event. I'm having a lot of fun here. And I also want to say thank you to Ease, my client who offered to pay for my flights over here. They are hiring in San Francisco if you guys are interested in that. But thank you very much, and I'm honored to speak for you.
Great job, Harry. I have a feeling that any questions you have for Harry are going to be long and involved. And coffee and drinks await.
Yeah, let's do some beers.
Hi. So I have a small technical question here.
Hi.
Yeah. So I have experience using Unity 3D, and it's like a game engine framework. And it works great if you stay inside the framework, but if you go into native, it's really hard to debug and it's really hard to just develop there. So how does it React Native? If you do something on the native side, is it? How does it work? Debugging and stuff like this?
Yeah, that's a good question. So like with a lot of like the Deliveroo version of the app, because the medical marijuana company, they have a distributed warehouse. Like so all the little cars that are driving around with people in them actually have like thousands of dollars worth of like weed and other stuff in it, like for the patients. You know, so all of that, like whenever we have issues with like basically the location code and the security code in there, it's a little bit of a pain in the ass to debug because you have to just go into Xcode, or you know, you basically will send traces to the server using, I think Segment is kind of what we use for analytics. So again, it's like, but if you're an Android or an iOS developer, it's basically the same thing as debugging native code, right? So, you know, like I haven't really dug into many situations where there's been an issue going back and forth across the bridge. Because usually, like from the Xcode logs, you can see like both the JavaScript logs and the native logs. And usually kind of problems kind of manifest themselves in one specific area. So the strategy that I use is to kind of isolate it to kind of like either a native issue or a JavaScript issue. And if it's a JavaScript issue, you know, it's not that bad to debug because you can just basically hook it up via Atom or whatever you're using and kind of step through the code or put in some logging statements. If it's a native you know, issue, you know, because I am an iOS developer and I've been doing this stuff for years, like it's just like native debugging. It's not really that much of an issue. So because the realms are kind of very cleanly separated, I generally find it's not that big of a deal. But if you don't know iOS development or if you're relatively new to JavaScript, it's kind of a pain in the ass. Oh yeah, one cool thing that I forget to mention is you can travel through time with React Native. So there's this really cool tool by Ignite that basically allows you, because React Native is functional, to replay basically all of your states in Redux, right? So you can rewind back up until the point that you had a network error and replay it again. So that's actually kind of like really cool if you're doing sort of development and you have a cool test harness with like, you know, web stuff or network requests in it. So yeah.
Thank you very much, Harry. We sadly running a little bit out of time, and I have again 2 announcements, 1 question, therefore, sorry. So first announcement is actually, I mistaken a little bit for the ambassadors. It won't be now, it will be after the conference, okay? So it will be at 6:10 when we had the last talk. Then please go over there for the ambassadors dinners and subscribe. Then question, who wants ice cream? Great, then I have another announcement for you. There is ice cream over there. Have fun. Ladies and gentlemen, welcome back. Before we start with our main program, I would have 3 questions for you this time. So I'm trying to operate in threes, but sometimes it's statements, sometimes it's questions. Now it's just questions. So who of you are still there on Wednesday? All right. Who knows about UIKonf unconference? Only a few people. So I will tell what it basically is. We have another location which we provide for you where we have a more casual way of doing talks, and we also have a small space where you can, for example, show some code to each other or have a small discussion panels and so on and so forth. And this will take place at Beta House on Wednesday. Who plans to be there? All right, thank you very much. Then please give it up for Jeff.
I hardly need applause to be encouraged to get on the stage. Our next speaker is deeply involved in security and all sorts of things spooky and whatnot. He originally started working on iOS back before it was an embedded system that ran on your phones, back when it belonged to Cisco. After that, he found himself invading Chinese establishments for fun and profit. And now he builds security systems. So please welcome Rob to the stage. He's going to talk to us about learning from our elders.
In 1977, John Backus, who helped invent Fortran and Algol, wins the Turing Award. And when you win the Turing Award, they let you give a lecture. This is his. Can programming be liberated from the von Neumann style, a functional style, an algebra of programs? I love this title. I love the word liberated. I think we should use that a lot more in software. Oh, what does he mean, the von Neumann style? Well, he basically means Fortran and Algol, which he helped invent, and this is his apology. Today, he would mean C. And what he's talking about is imperative programming, mutating some state step by step by step to get your program from one thing you have to something you want. And there's a lot of ideas in this paper. But the things that really fascinate me about it aren't what we think of as functional programming. Backus doesn't even mean, when he says functional programming, he doesn't mean what we mean today. He actually means a completely different thing. So that's not the important thing. No, what's important is that he says we can decompose complicated problems into simpler problems. We can transform those and make them generic, and then we could put them back together with rules, an algebra. That's what an algebra is. It's a set of rules for tearing things apart, transforming them, and putting them back together. Now, I want to be clear. Swift is not a functional programming language. Trying to make it one tends to lead to all kinds of headaches. Trust me, I know. But there are many, many lessons that we can learn from all the years and years of research, decades of research, that have gone on mostly in functional programming languages. So we're not going to talk today about immutable data or recursion or monads or obligative functors, none of that. We're going to talk about algebra, an algebra of programs. We're going to talk about composition. Now, building things out of existing and reusable pieces is better than building a new giant program every time you have a new problem. There are, the obvious benefits of code reuse, but really what's more important to me is comprehension. It is easier to understand small programs and reason about small programs than large, complicated programs, right? There are certain things when you encounter an enormous 45,000 file program, you just can't understand what's going on. I think most people today would agree with that. I don't think I've said anything controversial. In 1977, this wasn't a controversial statement either, right? Everyone already also knew about that too. So what's the point? I mean, we've all learned our lessons, right? We know composition is the way. We use delegates and protocols and keep our bindings loose. I mean, we don't build tightly coupled monolithic pieces of software like they did in the Fortran days anymore. Our classes do one thing, and they do it well. I know. This is composition, right? These are protocols. Discover View Controller is composed out of table view data sourcing and archive results updating and discover view model mode delegatingness. We got to put this stuff somewhere, right? An object that conforms to a bunch of unrelated delegates is not, or a whole bunch of unrelated protocols, is not composition. It's the opposite of composition. You took things that were intentionally split up into separate protocols and glommed them together into one giant object. I run into code like this a lot. You've got a table view, collection view, whatever, and it's got maybe a couple of states. You know, you've got your logged in state, and then you get all your Instabook tweets. And if you're not logged in, you get this one please log in cell, right? That's maybe really tall, right? So you have in each delegate method, you check, am I logged in, and you do the right thing. And then it's not so bad, but you add searching. And then it becomes that. It's not too bad. I mean, we can work with this. We're programmers. We can work with this. And then they call you up and they go, hey, you know, I want people who have never logged in to get some default content to get them started. But if they have trouble logging in, then they should see the error. But when they refresh, then they should get some cache content to keep them going. And that's when you go through the 7 stages of implementing a complicated feature in this code. There has to be a better way. Glad you asked. What if we used composition? I mean, actual composition. What would it look like? Shocking fact. There is no rule that says that your data source has to be a view controller. I know that's the default. It's not a rule. You are free to make a class, an object, that is nothing but a data source. Well, so what does that mean I can do? That means that I could break it all up. I can have a browsing data source for the browsing state, and one for the searching state, and one for the not logged or the logged in when I need to log in state. And each one does one thing. It just serves cells for that state. There's no if logic, right? Do one thing, do it well. Now, I can't get rid of my if logic. It has to be somewhere. There's the rainbows. This is the magical rainbow app. This is what makes your app special. It's the craziness. It's the kind of human-centric side. Humans want weird things. They do. And it's not bad. It means somewhere in your program will be weird. You can't get rid of it unless you get rid of your users, which is a thing, but don't. But you can put it in one place. I'm not spreading it out all over the code. Okay. So we broke this into 3 data sources. I want to look at these first 2, browsing and searching. And you know, they really feel like they're the same thing. I mean, one just has a filter on the other one. That's kind of wait, actually, I could just say they both have a filter, and one filter happens to say show everything, right? That's a filter. Well, if I do that, if I think that way, well, I could build one thing, a fetch request data source, right? And now I can make it generic, right? That's kind of nice. Oh, wait. That's not going to work. It's never going to work. I mean, it's fine, but we can't reuse it. We know we can't reuse it because everyone knows this is how you configure cells, right? In cell for row at index path, you grab a cell, and you have line after line after line after line of plugging stuff in all the right places. And that's a lot of code. And you've tried to put that in a closure, that's never going to work. And you're right. That's pretty bad. Because this is not right. You've broken MVC. This is not model view controller. You don't understand correct composition in Cocoa. Most Cocoa developers I know, and most programs that I go into, kind of get this. They get the MVC paradigm, right? The controllers mediate between models and views. Yeah, I mean it. Controllers mediate, coordinate between models and views. That doesn't mean they tear apart models and stuff them into views. They coordinate. They get them together. Think about strings and labels. The model object for a label is a string. It's just this model object. But when I display a string, I have to tear it apart into characters and glyphs, and eventually all the way down to glyphs, and they all need to go to specific coordinates. So, of course, what we all do is in our view controller, when we want to assign a string to a label, we tear it down into glyphs, pull each glyph out, put it into the label at the correct place, right? No. You just hand the whole string, and you say, label, you know how to display strings, go do it. So why do we forget that when I have a person object and a person cell? Just give the person to the person cell. It's the same thing, right? Let the cell be smart about what it's supposed to be smart about, and let the view controller be smart about what it's supposed to be smart about. That's composition. And when we do that, then all this crazy, logic, complicated logic, suddenly becomes one line of code, right? I just say, grab it, stick it in. Well, that's easy. And as soon as I do that, I go, wait, I could make an associated type. I could make this into a generic, right? Or not, and I could say, I'll get a cell, and I'll just stick it. I'll say, get from my models, stick in my model. Now, now everything's reusable. Everything's generic, right? Everybody solves one problem. And when I think about that, I can think about my other one, my login data source. And that really is just a static cell data source, right? And maybe I can figure that by handing it a storyboard and an identifier, or maybe I create a cell and hand it and say just every time give it back to me, or whatever you want to do. But now I have another piece of reusable code. And when you do this, you can start to think about much more complicated ones. I could imagine a simple array data source that I hand array to and it hands me stuff. Or I could have a network response data source, right, that handles all the process of going out and coming back. Now that's going to be complicated because networking is complicated. But you can write it once and use it again and again. And it puts it in one place. New example. I get this question asked all the time. All the time. I've got this list of names and this list of ages, right? And I kind of want to sort them together. I'm sorry, it's that, right? Together. So that I sort the names, and when I get them in order, I want also ages to be sorted in order. And people ask this on Stack Overflow a lot, and somebody will always helpfully come along and tell them the solution. It's easy. Well, you zip them together, and then you sort it into tuples, and then you sort it, and then you unzip it, and then they go, oh, yeah, right, there's no unzip in Swift, but that's okay, here it is. Here's the little unzip, and easy. And then you add another array, right, for the user IDs, and you've got to remember to sort that one too. And every time you add a new field, you got to go back and remember all the little places that you touched all this. And every time you have insertion logic, you got to remember to insert them in the right order. And you have to deal with moving. That gets really complicated, right? And you finally get it all working. And you put it to bed, and you go off to do other things. And your boss calls you and goes, hey, could we sort by managers first instead of name? And then sort by name? Yeah. And you look at your code. What if we used composition? What if we turned it inside out? Instead of having many arrays of one property each, we could have just one array of structs, right? And it has many properties. See how I've turned it inside out? The mathy word for that, by the way, is a dual. We've created a dual. It's very nice. Instead of spreading that information all over the program, we've put it all in one place, and now when we add new fields, it doesn't matter. It's all easy. And what did we do? What did we create? We created a type. That's what helps us there. And instead of making it easy, we made it simple. A type. What's a type? Let's think about this thing of every value. You've got some variable of some type, and I want to think of every possible value it could hold. Everything. So for an int, there are 2 to the 64th possible ints, right? They can be held. And it's not infinite. I mean, it's not every int. People say, ints are integers. Well, no, they are the values between, in a certain range. There's a set of them. I can think about strings. Strings, I don't think there's a word for the number of possible strings, but again, it's some finite number of possible strings. It certainly is not every possible value. And I can even think about things like dictionaries. I mean, there are values that are dictionaries and values that aren't dictionaries. So again, I want to think about everything I could possibly put in there, and the program compiles. Now, then I want to think about the values that could go into this variable that make sense in this program, right? So say you have a state, and you have, loading, viewing, and editing. So there's 3 states, and you're going to store it as an integer, 0, 1, 2. So an integer can hold something like a quintillion values, and you're using 3. We're going to call that weak. If you're using a string, which, as I said, I don't even think we have a word for how many possible strings there are, and you're, say, holding, 20 keys, that is an insanely weak type. Now, that doesn't mean strings are weak. Strings can be strong. If I'm downloading stuff from the internet, any conceivable string could conceivably be on the internet. Therefore, that's the proper type. That's what I mean. But if you could count up all the possible legal values, then string is not being used in a strong way. So here's kind of the maybe counterintuitive part. When we want to make our types strong, we shrink them. We give them fewer values. Ideally, if we can really pull it off, we have exactly the same number of legal values as possible values. Those two things are exactly the same. Types do a little bit more than hold values. I said they're a named set of values, but they also add a thing we call context. One of the contexts that it holds are a set of invariants. These are things that must always be true in my program. So if I think about that list of names and ages, one of my invariants was all of the names and all of the ages will always be in the same order. They will create an order that is the same, that matches, and that they will all have the same number of elements. It would be considered a programmer error if I ever got into a state where those two arrays were different lengths. Okay. When I had a bunch of arrays, to enforce these invariants, I have to write preconditions, right? Or fatal, I have to put in these things that check for that at various places and crash the program if it doesn't work. Or at the very least, I have to write unit tests to check all those things. And if I don't write unit tests, I could just hope, right? But hope is not a great strategy for enforcing invariants. But when I turn it around and I have an array of structs, it is impossible to violate my invariants. The program wouldn't compile, right? There's only one array. It can't be inconsistent with itself, right? So I don't need tests to make sure. The more places that our types can hold illegal values, the more time we spend writing preconditions and unit tests to make sure that they don't. The more constrained our types, the stronger our types, the more whole classes of bug are actually impossible. They could just not happen. The compiler wouldn't let us go forward. So stronger types means fewer tests. I would rather have code that obviously has no bugs, that is so simple and so type constrained that the only possible implementation or the only possible way that it could work is correct, right? Nothing else would build. I would rather that's my ideal, than a program that I've tested a lot, and so I kind of feel like it probably is fine. What does that mean in practice? How do we do this? We have to look really carefully at our squishy types and make them stronger. I'm going to start with the squishiest type in Swift, which is any and any object. They're really close. There's not a lot of reason to separate them. And it is arguable whether the unsafe types are even squishier, but any and any object are pretty darn squishy. They can hold any value that Swift can talk about, right? It is rare that you mean that. I mean, you mean seriously, when you say, I take any, you mean literally, I hand you anything at all, you're cool with it. That's fine. Print comes to mind, right? Out of standard lib, print means it. You can hand print absolutely any value in the entire Swift type system, and it says, I'm good. That is rare. I can think of very few cases where that comes up. Now I know, Cocoa generates any. And it generates any in one particular place, JSON parsing. Can we talk about anything else except for JSON parsing? It's the only thing we talk about. But JSON parsing, yes, I admit, JSON parsing generates any. Because JSON is full of any. JSON is not full of any. Actually, any is a lie. There are certain things that are legal JSON and other things that are not legal JSON. There are certain dictionaries that make sense in JSON and other ones that don't. The problem is Cocoa gives you a lousy type for it. Don't fall for it. Fix it. You can fix it, move the stuff out of any and get it into something else, anything else, right? A class, a struct, an enum, something, an int. So, once you're done with the parsing, any should go away. After any, dictionary is probably the most abused type in Swift. And I'm not even counting dictionary of string to any object. We've already been there, because that's just doubling up. But a dictionary is an arbitrary, it means something. It is an arbitrary mapping of keys to values. Arbitrary. That means any legal key should be okay. You should feel okay with any key that is in that type. So let's look at this. This is really common. Dictionary has a key name, it has a key title. So my next dictionary line, I'm going to have dictionary, and the string will be the entire text of War and Peace. That makes sense. That makes no sense. The next line is going to be address. We all know the next line. The next line is going to be address or city or phone number. There's going to be a small set that it's going to be. It's not going to be just any old string. And you're going to go, oh, no, it's okay, Rob, it's okay, don't worry. I'm going to use string constants. Use a struct. When you use a struct, now all those problems go away. I don't have that problem. I use a stronger type. This use of string in weird ways has a special name. I didn't realize this was its special name until recently. It's called stringly typing. This shows up, actually, and what's funny is this shows up in every language. Every language complains about stringly typing. I thought it was just us. Let's think about this code. You're switching against start and end. And then you have a fatal error, because you need to check the default case, because maybe it's not one of those. And again, you go, no, Rob, I'm going to use string constants. It's fine. String constants fix nothing here. Nothing. That's not the problem. The problem is fatal error. You just put a line of code in that should never run. Why would you want a line of code in your program that both should never run and if it does, crashes? I don't want that. That's bad. No, you want here an enum, right? Then all of a sudden I don't need default. It just works. And you go, oh, but I need to be able to see them as strings. It's fine. Swift can do that, right? But I don't have to have fatal error. Every time you find yourself writing fatal error or anything else along that line that's going to crash the program, you should be thinking, could I have better specified what I have in a type? How about lowly int? So, yes, ints sometimes are used when enums should be used. True. I don't want to talk about that. First off, I find that most people get that. Most folks, when they have ints that should be enums, they use enums. Swift makes it pretty easy, and most people get it. It's no problem. And that works when there's a fixed set of values. But what about this? So, and this comes from my code. This actually is what precipitated half of this talk, is this little structure I had. It had a few more fields. But it had an ID, and I had this ID that was an int. It's an identifier, right? Unique identifier. That was an int. And what happened is I wanted to switch it to be a string, because we were going to do things a little bit differently, and I wanted to use a string there. And I had to walk through all of my code looking for all the places I'd used ints to see if it might have been an identifier. That's a lot of places. The more I thought about it, though, I mean, yes, that was very frustrating, but it was worse than that, because is there anything number-ish about identifiers? I mean, at the time, they were implemented as numbers, but can I add them? I mean, you can't add identifiers, but I can add ints. Can I divide them? I mean, that's insane. That doesn't even make sense. No, what I can do then is I lift. I give context, and I turn my identifier into an identifier. I give it a type. Right? Now, all of a sudden, you can't add IDs, right? That's prevented. And when I wanted to change the value type to something else, I wound up having to change, I think, 3 places in the code. And the compiler told me exactly which 3 places they were. That's what I get with a stronger type. Now, not all things in Swift are types that look like types. One of the weird ones is protocols. Protocols are not really types. Call them type-ish. They're type descriptions. They tell you what a type would be, what kind of type I want. It's important that we understand that they're not exactly the same, because I want my types to be strong, but I want protocols to be weak, very weak as I can get them, right? Because say I have a protocol that only has one requirement, right? Has this one line like custom string convertible, just you have to implement description. Well, that's really nice. We like those kinds, right? But that means, in principle, huge numbers of values could be of that type, or of that protocol, right? Huge numbers. Well, that means it's weak, right? And that's good, but that's good. I like that. I don't want to make lots of constraints on my protocols. I want lots of things to have them. I want them to be easy. So I don't want to create restrictions I don't need. What about generics? Generics are funny because they're not types. They are functions that generate types. It's weird because in Swift, the syntax can confuse you, but they take a type parameter and they return a type. It happens to run, these types happen to run, or these functions happen to be evaluated at compile time, but that actually doesn't change much, except one big thing, which is while they are functions, they are not first-class functions. In Swift, we can have first-class functions, right? We can hand around functions as a thing, but not type functions. They're not first-class. We can't talk about an array, just an array, nothing else, right? And some languages you can. That's not absurd. It's a feature. It's called higher-kinded types. And you'll see people talk about that sometimes. I wish Swift had higher-kinded types. What would that mean? Take this function. This is illegal. I can't do this in Swift. Right? I have to add a type parameter. Why? I don't use t anywhere. Why do I have to pass it? This gets worse if I stick it in a structure. I can't have this. I have to, not only do I have to have a type parameter, but it escalates. All of a sudden, lots of things become generic, where nothing needed to be generic. So that's frustrating, right? We can get around it. There's type erasers. There's weird little boxes you can use. But it restricts what you can say. It constrains the kind of solutions we can write, or at least that are easy to write. What you can say influences what you can imagine, and what you imagine controls what you can build. That's why I'm bothering telling you all this, right? Teaching you weird vocabulary. A lot of this stuff is type theory and the like. It's because when you can imagine a better type, when you know that such a thing could exist, maybe it doesn't exist in Swift, but you know it could exist, then all of a sudden, you start looking for ways to solve that. And maybe you can't do it as beautifully as you'd like to, but suddenly you can build things that make whole classes of problem trivial. Let's get back to a practical version, right? We're going to try to change this around and fix its shape. We've got this thing, it fetches something, and when on completion it gets maybe a string, and maybe an error. What the heck? This is horrible. The horrible part is this. Maybe a string, maybe a string. I don't know what that is. What does that mean? Well, I'll fix it. I'll put labels on it. This is worthless. This is totally worthless. This is a comment in Swift. This doesn't actually have any influence. You could put any strings you want there, and when people call it, they can change it to any other strings. These are just labels. They mean nothing in Swift. So that's not great. There's this other problem, though. I have name and address and error. How are name and address and error all related? How do they fit together? The answer is they don't. Name and address kind of seem to fit together, and error is something completely different. I wish I had a way to say I want name and address. I want a grammar. I want a type language where I could say the word and. And we have that. It's called a struct. A struct, we call it officially a product type. Why do type theorists call it a product type? Well, how many values are there of it? When I have a struct of style and I say I have 3 colors possible and I have 2 possible thicknesses, how many possible styles are there? There are 6. And that's the total number of possible values that struct can hold, because it is a value. The whole thing's a value. Okay, so I'm going to use an and type, and I'm going to create this thing, maybe a person and maybe an error. Now you see, I'm saying and. I'm still saying and. That's because a tuple is also an and type. They're very, very similar to like an anonymous struct, so they have the same rules. But, I mean, I like that. That's pretty good, because I can just read off. I don't need labels. Notice how no label problems. But it doesn't make much sense. I mean, I don't know if you can see this. Not all of the cases make sense. What if I have a person and an error? I mean, both of them show up. Is that legal? I don't know. What about neither? Is that legal? Do I have a fatal error? Do I ignore it? I mean, I don't know. You have to think about it. I hate to think about it. Why would I do that? No, because I don't mean maybe anything. I mean a person or an error, one or the other. We want another type. How do I say or? Enums. Enums are or types. For the same reason that product types are product types, or types are sum types. How many possible styles are there? There is 1 kind of line. There are 3 kinds of squares. There are 4 kinds of styles, right? Sum type. Okay, that's nice. So now, I want to be able to say that. I want to be able to say person or error. I'd like to make it kind of generic, and I'm going to show you this because this is the common way people who are used to this kind of thing do it. We all create the same type called result. We all wish that Swift had it built in. There is much debate as to why it is or isn't, but you can build it in 4 lines of code, so please do. And I build these all the time. Don't think you need a big library. I mean, I just build them. It's okay. They don't cost anything. But now I have a successful value or a failing error. Context. Again, context. So where does that leave us? Instead of this string, maybe, I have a resulting person. Now, you do need to learn that resulting means could fail. But other than that, everything's right in the signature. I don't need comments. I don't need labels. And that's what I want. And the compiler is going to enforce that I do it all right. And that's the lesson of functional programming that I think we should bring to Swift. Complicated things can be broken down into smaller, simpler things. And we can find generic solutions for those simpler things. And then we can put them back together with rules and composition. And when we do that, the compiler can make all kinds of bugs impossible. And that's a lesson that I think that both John Bacchus in the 70s and Krusty today would both agree with. Break it down, build it up. Learn from our elders. Thank you.
So thank you so much, Rob. I know I enjoyed learning from my elder. You knew that was coming, didn't you?
Oh, yeah. I'm good with it.
I think we might have a moment or two for a question.
Okay.
Has anybody got a question, Rob?
Stunned.
Question? Do we have a microphone?
So I'm not sure if I should, hello?
Yes.
I'm not sure if I should in public, but I'll do it anyways. So I built this.
Sorry?
Yes, so the question is, I built an event system, and so you could raise an event and you can consume events, and as a parameter you can pass a dictionary. It's a string object, so it's very flexible, and it's very unsafe. I'm aware of that.
Right.
But so maybe you could comment. Is there a better way? Or
well, but I mean, what's the dictionary for? What's it achieving?
it's just passing arbitrary parameters, because every event has different kind of data you would give.
Well, that's an enum with data. You can now store data in the enum, so each event type is an enum, and its parameters are its data. That means it's impossible to have it be wrong.
Hello, thanks for the great talk. Do you think it's possible to achieve all those with a mixed program with Objective-C and Swift?
Oh, certainly, certainly. Objective-C, many of these lessons, I use the same techniques in Objective-C. Objective-C does make certain kinds of types harder. Its type system is not as strong. I still have rarely needed a dictionary in Objective-C. I railed against dictionaries back then, too. You can still make a class. Making small data classes is exactly the same as making structs. I haven't mentioned classes, but they're also product types. They're exactly like structs. So I would do that. Enums are not nearly as powerful. That is a place that's very difficult to get the same power in Objective-C, which is unfortunate. But oh, certainly, certainly. Almost all of the things you do here translate to actually most languages. To differing levels on how strong their type system is.
Yeah. So is there any way to restrict the int, for example, even more? Or is uint the most, say?
Don't use the uint.
Yeah.
So
say
in the much longer version, actually I've taken it out of all my talks because it confuses people. Yes. It feels like if I know it should be a positive value, it feels like I should use uint. You should not. Uint does not mean positive integer. That's not what it means in Swift. It means bit sequence. So if you mean bit sequence, then use uints, because uints have a lot. There's two problems with using uint. One is they have certain magical properties in how they overflow and underflow and things. They also, which is different than int, so they have context that is not I'm positive. The real reason that you really want to avoid uint for numbers is because the math gets very surprising. Because uints are not closed. Their algebra is not closed under subtraction. What that means is if you accidentally create a negative, you get shocking results, right? That 1 minus 2 is greater than 1. That's a violation of the basic rules of a ring. But the thing is, don't do that, because you're creating a context that you don't mean. And the right way to think about it is uint means I want this sequence of bits. So for instance, when you're doing byte data, uint8 is the right tool, because that's what you mean. Yes?
Last question. Whoa, last question. Free.
Oh, I did want to say, there is a lot of work in other languages on this question of, well, how would I make an int that's always positive? That's a feature called dependent types, and Swift ain't never going to have that.
Yeah, last question over there.
So, hey, I have just one question about the type erasure. Are you on the side of, would you like to have types that you could strongly type, like let's consider that you could have a sequence that the key is actually any generic type of, I don't know, self-associated type, but that would lead actually to, for compiler to probably to optimize for all possible values that can be there, or are you still fine with the type erasure that
yeah, the question is probably is kind of like, how should we currently have to do crazy tricks if you have protocols with associated types? When you have protocols with associated types, they're not types in Swift, and they're very hard to use. And almost 100% of the time, the correct answer to that is a type eraser, which is a funky construct. Swift should write the type eraser for you. And the compiler teams talked about that. That feature is called existential types. And you'll see it pop up all over the place. People talk about existential types. But the compiler should generate them for you. It doesn't. That, though, to me, it's not really a strong type issue so much as just language annoyance. I don't like that we have to build type erasers, but it's kind of what we have to do. I think that was it.
Good.
Get the hook.
Awesome. Thank you again, sir. Well, I know I learned a lot. I almost feel like I could write some Swift now. So our next speaker is TJ, and I could pretty much listen to TJ talk about almost anything. He's one of the few people I know who almost anything he talks about, he's informed and an erudite. And today he's going to be teaching us about programming languages and languages in general. And please give a warm welcome to TJ. Man, pleasure.
Thank you. Let me move this. Can you all hear me? Let me move this a little bit. All right. Hello, everyone. You have come here to watch me type. All right. Again. Thank you. So, my talk, which many people had bated breath, waiting for the topic, is about programming language. And it's not about programming languages, because really, who wants to watch a talk about just programming languages? I say as though I would not watch said talk. Really, it's about programming the language that we use, like all of the languages that we use. So spoken language, written language, when we talk about things, we're programming each other, we're programming ourselves, and we often sort of have resistance to this idea of considering what our words mean and the way that we construct sentences, right? So recently someone on Twitter sort of just asked into the air, and the correct quotes there, when I use the word dudes to a mixed group of people, is it weird? Is it offensive? And you're sort of like, yeah. I mean, we've gone over this. It's a thing. Please stop. Just try harder. And really, that resistance is refusing or having a problem sort of acknowledging that our language is a tool that we use to shape thought and to share thought, right? So I'm going to imagine that I have some deep understanding of how language came to be. I'm imagining in a way that helps my narrative work. So if you have a deeper understanding and you come talk to me later, that's great, but this works for my story, okay? So I'm going to imagine that initially, right, before there were words, right, and there were a bunch of people, we had to create early abstractions, just basic, the most urgent abstractions that we needed. And I would ask the audience for examples. In fact, you, sir, what is one urgent example that you can think of that you would need as you think caveman, think like fire? Well, that's a little late, but I would imagine food, right? Food, right? That is like one urgent thing that you would need. You'd want to be able to say that there is food, and I guess you would also want to be able to say over there, right? Or I found food, or you would want to be able to shout food or something like that. And then maybe first, I don't know if food or danger would come, but very close, right? Once you figured out that you could represent things like that, then maybe shelter. And after all of that, maybe the specifics of it, right? Like maybe at first, all you can say is danger, just general danger. And then eventually you start to say, oh, danger like something that might eat you, or danger like you might fall, or danger like, it's sharp, or something like that. And all of those things, in my opinion, are early abstraction, right? Just early abstraction. After all of that gets sorted, or at least enough of that you start to have some maybe grammar or some idea of, yeah, this is a thing that we do. We express ourselves with our voice. Then maybe you start to think about yourself and being something. And like, I found this food, or I found this, or, I'm going to eat, or I'm hungry. And I think that order is fairly important, because we have an idea of self, and we would like to believe, and honestly, I do believe, that it is something that separates us from animals or something, right? And we can have long discussions about that later. I like long discussions. But after we have this idea of self and others, right? Because along with the idea of self, I think, comes the idea of someone else. Then we have this idea of narrative, and selves interacting, and other things being involved. And I swear to you, this will come back to programming in a period of time. I cannot guarantee you how long it will take, right? And then we sort of start standing on the shoulders of giants. After all of those things are met, after we can tell stories about ourselves and dangers and food, then we start having these abstractions that we pass on. And math, right? Or science. We start talking about things and then learning from someone else who, taught us first sort of where the danger is in general, or how to recognize danger. And then we built on that, right? And I really want to circle back to this thing that I said in passing, that language is a machine, and we should probably define what I mean when I say machine. A machine is any device that transmits a force or directs its application. And in this case, our force is our mind, right? Our thoughts. The idea to consider and project into the future and consider the past. So, why do I care about all of this? Why have I gone on for a few minutes about my conjecture as to how language came about? Well, language structures the way that we, represent concepts. And I tried to take a picture of Rob's slide where he talked about what we can say shapes what we can imagine, because this is the same idea, right? If we have a word for it, we are influencing how we think about a thing. So when we say, hey, you guys, or hey, dudes, or whatever, we're shaping how we address a group of people, or the specific group of people that we're addressing. All right, so I'm going to skip this blank slide that would have a lovely picture of Rob. Now, I told you eventually we would get to programming. And here's a lovely, fairly simple, if you already know Swift, but if you don't know Swift, it's okay, I'll talk you through it. At the beginning, we have a description of what we accept in this function named lengths. We accept an array of strings, and we return an array of ints. We have a variable called counts, and then we iterate over that array that we received. We count the characters in the string, we put it in the array counts, and we return that, and it seems pretty clear what we're doing. Now, I'm going to argue that yes, this is clear. It's perfectly clear. Right? But there is something about how we have described this process that doesn't capture an aspect of what we're doing. This is doing the same thing. It has the same end goal. It has the same name. But this time we're mapping over the list. And in this map, we hand in a closure where we take one item and we get its count of characters and we return that. And then somehow map handles the creation of the array. Now, honestly, if this is all you're doing in the function, I have no argument as to which one you use. I really don't. Both of them are clear. Both of them convey what you're doing. But this, in my opinion, captures the idea that we are transforming the first list into the second list, and that there is a matching of order and structure to those lists. That's why I love map. Right? I really appreciate the fact that if I see the word map, I think to myself, I am preserving structure, and I'm making a new thing that has the same shape in general as the first thing. So is this a functional programming talk, TJ? Like, are you gonna take this further, right? We just heard Rob tell us that Swift is not a functional programming language, right? So are you gonna come on here and contradict Rob? Of course I am. Of course I am, right? Of course I am, right? Now I'm not really gonna, contradict him too much. I mean, but yeah, I like contradicting Rob. It's a thing. I followed him all the way here just to do this. Right? No. The thing that I really care about is that when we program, when we speak, when we interact, we're developing language, right? And now I'm going to talk about programming languages and programming, and I'm going to try to match the narrative of sort of how we work through developing programming parallel to what we just spoke about. What do I mean? Now, this is not strictly the order I believe that programming has worked in, but we'll talk about that in a moment. But early abstraction is probably like a Fortran or a Algol or machine code or whatever, just basic things in programming. Right? We, back some time long ago, some people put cards in machines and found a moth and called it a bug. Yeah, early abstractions, right? We have this thing that we want to do computations with, and we figured out a way to make that happen. Cool, great. Well, we're still there, I think. We haven't really made things that much nicer. There's a phrase in Python, batteries included, that I have, honestly, for maybe 10 years, really adored. And it's this idea that you have an ecosystem where if someone comes in and they say, I like geology, and I want this computer to think about geology, or I want to use this computer to think about geology, the batteries should be included when they start to learn Python. They should be able to say, like, import geology, and then just do geology. Whatever that means, right? Just do it, right? And yeah, I think that is the important thing, and this is why I like functional programming. But honestly, functional programming is not the point. And you might say again, but TJ, don't you want to marry functional programming? No. I have, and don't read this code. There's a lot of it. It's very tiny. That's not the point. I write all of this nonsense. It's beautiful nonsense, in my opinion, because I wrote it. So that I can get to this, which is a little bit better, right? But I have realized over the course of the 8-9 years that I've been writing iOS code and just writing code in general, that I don't really care about the programming that I'm doing. I care about language. I love language. And so I can look at a functional programming construct and love how math is captured and how when you use the word map, you're conveying some idea. But I really, in this example, right, what I actually cared about is what's at the bottom. This idea of a grammar and clearly conveying the thing, and you can see it sort of hidden in those lines up there beforehand. That's the beautiful thing, in my opinion. And this idea of abstracting away to where someone who cares about grammar and cares about language and linguistics, I want someone to look at my code and within the nonsense of Swift, see something that they know and that they can speak about and say, well, based on the fact that I see this, I can sort of guess what the rest of it's doing. And I feel like as an industry, we're not really marching towards that at a pace that is reasonable. Right? We still hold a lot of secrets. It's still code. Right? Now, more examples of sort of why I really get up and write code. Hopefully you all can read this at the top. This is another example from that same library where, given 2 strings, I can tell you, all right, well, this is a grammar that accepts both of those strings. Or some math, right? Because I love some math. I'm sorry, Maxim. This is as much math as I'm going to sneak in. Okay. He was like, we're at the end of the day, maybe you don't do a lot of math. Maybe don't do that. Maybe don't do that. And then this is the library that I've been working on for a very long time. And it's a music library. And again, my goal is to capture the language that you would use as a musician, as well as I can as a developer. So that yes, if you know Swift, you can figure out what the library does. But if you don't know Swift, maybe your knowledge of music is the entrance to figuring out just enough Swift to do geology. Right? All right, so now I'm gonna throw a curveball and say, all right, well, we have this whole idea of self and identity. What does it mean to be a programmer? And earlier today, we heard, I'm not really a computer scientist, which is specific enough for me to say, okay. But I want people who write lots of Swift or lots of programming, programs, to say, I'm not really a programmer. Because what this means is that they were passionate about something. They imported geology. Yeah. Someone's going to make a library named Geology soon, right? And then they did geology. And they did it in Swift or Python or whatever so much that someone was like, you're a programmer. And they were like, I'm not really a programmer. This is a sign that we have included the batteries, that we have succeeded in actually capturing language and abstracting things away to the point where someone achieved something that they know about, right? Like they took the language that they had and they weren't held back by this language that we made. Now, we made all the language, sure, but we are very deliberately making programming languages. Some people would argue with me about the word deliberately in that sentence, but we're doing it, right? And this is one of the things that I just want us to think about a lot, right? We have a new opportunity with this new language of Swift to decide what our ecosystem looks like and decide who we try to include in terms of just domains of knowledge. As an iOS developer, right now, what being an iOS developer meant before Swift was that you make iOS apps. And that was the primary thing that defined a lot of what you did. And yes, there were a lot of people who came into it for fun, but you made iOS apps. Right? And That's not likely to change too dramatically, but I want to recapture that idea of the first few years of iOS where people who were like, I like cats, so I made a cat app, right? I like fish, or I like geology, right? And that was it. They were not trying to become contractors or whatever, and that paying the bills is fine. But they saw this opportunity, and the barrier to entry in terms of language was low enough that they made it. Now, okay, so now I'm gonna preach at you a little bit. Please mind your pronouns. And now, when I say mind your pronouns, I don't literally just mean mind your pronouns, right? When you say he, she, they, you, dudes, whatever. I mean, think about the words that you say. Think about the words that you choose. They're meaningful, right? When we talk about programmers and we say a programmer receives a spec and we've made a decision, right? I would love if we used the gender-neutral pronouns because that would be amazing, but that's not going to happen soon, right? There's a little bit of a leap there. But you can say they, or you can switch it up, or you can, even if you just forget and go through a whole long narrative with he's, just acknowledge that you did that thing and move on. Don't push back, don't get bitter, don't pout, whatever. Because we are programming people with language. In the same way that we are deliberately creating programming languages, we are deliberately choosing the words that we use to describe the people who do programming. Presence is language. Representation is language. Now, all you people are lovely. There are not a lot of people in the room who look close enough to me to say that I would say that they look like me. And that says something. That is a statement. Now, we're diverse, right, in the room. I'm not saying that, we need some magical number or whatnot, but whenever you enter a room and there's an absence of people who look like you, and it's a community, right? It's not a random gathering. You have to make an evaluation of whether or not there are few people who look like you because there's danger to people who look like you or act like you, and I say look. I should be careful because I'm making a choice. It's not just look, it's who act like you, who believe like you, or whatever. When you enter a space and there aren't people who resemble you in some form or fashion, you have to figure out pretty quickly, is it because there's danger? Is it because we didn't know about it? Is it become whatever? And depending on your identity, this evaluation can be life or death, right? You can enter a space and find out that you are not just like mildly unwelcome, that you genuinely should have left immediately. And yes, this is a heavy thing to say, and like I said, I'm not necessarily condemning anything in terms of the space, but children see this language much more clearly than we do. If you show a child a bunch of programmers and they all look a certain way that is not like that child's going to infer something. So we're programming, like we're creating language, we're making decisions that convey something. Some of it is about context, right? Some of what we're saying by having a certain makeup is that historically, people who blah, 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 sure. Right? So it's not just current intent. Sometimes it's past intent. Sometimes it's happenstance. Right? All right, so we're going to take a moment, clear our palates. It was a bit heavy. People stopped laughing. There was a chuckle. I feel you. I feel you coming back, right? And after that, then we can get complex narrative again, right? Like, once we figured out sort of what it means to be a programmer, who programs, and all that stuff, and we have basic language, we can start to make more complex things. We can build a community where we say, we write programs, and let's write more complicated programs, right? Let's do this together. And that's where I feel like we are, but I also feel like we jumped directly to here immediately. Once we were like, What's this? I think I'll call it a computer. Ah, yes, now we have computer societies and we have universities and all of that cropped up, and we still haven't sorted out the early abstraction thing. It's still really hard to say fairly complicated things that are divorced from the computer's inner workings. So, yeah, I think we have a lot of work to do here. Like, this is what we do when we write iOS apps. This is what we do when we write servers that communicate with clients, that communicate with embedded things. This is complex, but there's still a lack of abstraction. Right? My apologies. And then shoulders of giants, right? This is still, we love this quote in the programming community, standing on the shoulders of giants. Right? And I think we jumped to this idea a little more quickly than we should have. We still have a lot of groundwork to do. We still have a lot of sorting out what it means to be a developer, what we want to capture in all of these languages that we create every day. Right? There's basically a new programming language, probably within the span of this talk. Right? And for what? And I don't say that to belittle the effort, because I think it's beautiful. But I really think that there's an opportunity for us to reconsider what it means to create programming languages and to program language and to speak to each other, and what are we trying to actually accomplish with all of this software. Right? Yeah, venture capital, angel investors, whatever. But what else? Right? Because all of those things come and go in a way that language outlasts. If someone comes to your programming language or your platform or your app or the things that you've built 20 years hence, what are they going to infer from your motives, right? If someone looks at my code, they'll say, he wasted a lot of time on some music and math stuff. You really liked that. Didn't ship much, but really liked that, right? And that's true, and I like that. I'm okay with that. So what are you saying with the software that you write? What are you saying with the people who you invite into your community? What are you saying when you talk, right? In the various ways that you talk. Thank you.
Thank you so much, TJ.
Terrific.
Us.
No one meets the wizard.
Whoa. Are we safe yet? Wow. So we have time for
2 questions.
Yeah, we have time for 2 questions. So has anybody got questions for TJ? Anyone?
Crushed it.
You did. You did.
Wait. No
All right. Excellent. Oh, there's a question right there. And another one over there. All right. So that was 2.
Those are 2.
Who goes first? Thanks for the great talk, TJ. Something about when you create a new language, like I mean, it's a little bit like a domain-specific language, like for music or something, that also creates an additional thing that you also have to then teach or learn the language for other people who use it.
Sure.
So the question is like, how would you like approach not only like creating the language but like teaching it?
Okay. So that is a good question, and I think that depending on the domain specific, like depending on the thing that you're trying to write a new language for, or some smaller embedded language for, that question gets answered different ways, right? So for instance, in the music, actually, in Swift, the simplest way, I think, is playgrounds, right? The nice thing, the beautiful thing about playgrounds is that if you just import the library where you have your domain-specific language defined, at first, you don't teach them Swift. You teach them just enough to make a variable maybe, or not even that if you have nice descriptions. You just say, use this language. And then you can sort of, in a backwards sort of way, start with the domain-specific language that is comfortable and is familiar, and then slowly teach Swift constructs to flesh that out and do more.
Last question.
Okay, hi. Thanks. Great talk. What's my question?
Good job. Thank you.
No, it's good. Do you think that the plethora of paradigms that we have in the programming world today is a result of the lack of the abstract, the fundamental abstractions that were missing that you mentioned?
Excellent. This is exactly why I've given this talk. No, I think that I halfway agree with that statement. I think that part of why we didn't have the abstractions, though, is because computers are hard, right? So some of us being tied to how the machine works is because that was really important in the beginning. You couldn't necessarily write a language where you could completely abstract away, and I recognize that, right? So C took hold for good reasons, right? It was not arbitrary that something that cared so much about how the machine works actually succeeded. I think that part of what draws me to functional programming is that there is a sense of, but what about the abstraction that was thrown away a little bit with C's success? And I think that returning and sort of reevaluating and trying to find more general abstractions and sort of get back in touch with the idea of, is there a way that we can step away from the computer and not even step away from what the computer's doing, but put a buffer between your understanding as a developer who just wants to have this beautiful abstract language that you work with, and then enabling that via actually really caring about what the computer's doing. And I just don't think that we have a sturdy enough barrier between those two things. Right now, all of these languages that are more abstract tend to be scripting languages where you say yes, but then you give up efficiency, or you give up this or that. And I don't want to give up anything. I want it all.
Well, thank you again.
Thanks.
Good on. All right. So my understanding is that there are hosts for dinners. Is that correct, Maxim? And that concludes day one, I believe. So please join us here tomorrow at 10 o'clock. And until then, have a great evening. Okay.